You are very warmly welcome to this seminar today at EVA, where we will be hearing two of modern time heroes and heroines, if you like. It's very important, this kind of frontier research, which also space research is all about, to see that what is the capacity of mankind to really attack huge challenges. And I think I remember when I was a PhD student, we were talking about, that how long is it going to take before we can sequence the entire human genome? And I thought it was going to take, with the current technology, more than 20 years. And I made a bet, and I almost lost the bet, because actually this became a challenge for humankind, which I actually used to afterwards say that, this was as big a challenge as taking the man to the moon. So it tells also how important these kind of escapades are. Well, a lot of people will collaborate. The best talents, in different kinds of sciences collaborate. And then we actually are capable of achieving things that were unimaginable when we started. I think this also, the kind of achievements that our two astronauts have done together with all of the colleagues, is also giving me hope, that we are also capable of attacking the other great challenges we have, not the least, the climate challenge. I'm also particularly happy of the gender balance today, that we have representatives, we have a man and we have a woman who both have had the courage and the knowledge to take on these fantastic missions in the space. So most welcome, all of you, most welcome to our two wonderful astronauts, and I hope that you will enjoy the seminar. And I will give the word now to Anders, who is going to be moderating the seminar. Thank you very much.
Thank you, Professor Thierry, and thank you for EVA for hosting this conference today. I would also like to say welcome to you, and I'm glad to see so many people here, and I can assure you that we have a very exciting afternoon ahead of us. So my name is Anders Salman, and I work at the organization Public and Science, and I will be your guide through this exciting afternoon. And the organization Public and Science, Vetenskap och Allmänhet, VA in short, is organizing this conference together with the company Umbilical Design. And we would like to start with to extend a thank you to our collaborating partners to this conference, the Japan Society for the Promotion of Science, the Sweden-Japan Foundation, the Swedish Space Agency, the Swedish Space Corporation, the Royal Academy of Engineering Sciences, EVA, Scandinavia-Japan Sasakawa Foundation, and the Swedish Astronomical Youth Association. So thank you very much for organizing this conference together. So this year marks the 150 years celebration of diplomatic relations between Japan and Sweden. And the two countries collaborate in many areas, not at least space. And as you probably know, there is a large interest for space and space exploration among the general public. But despite this, there is still a demand for educated, qualified engineers and scientists, and we also need more young people to pursue a career in science and space exploration. So could the large public interest for space help to improve this situation? These are some of the questions we will explore during this afternoon. I will invite you at some certain points in during the conference to ask questions, and I don't know if you have noticed, but you have microphones between your chairs, so please take note of that. And when you would like to ask a question, you just take up a microphone and press the button until it glows red, and you will ask your question, and then you can press the button again. Because it's important that you ask all questions in the microphone, because this seminar is being streamed live on the web as well. So I would like to say welcome to all our web viewers also, wherever you are, perhaps there, somewhere in space. And if you would like to take pictures or Twitter from the conference, you can use the hashtag EvaSpace, because we're at EVA and we're talking about space. So that's the hashtag, EvaSpace. So, without further ado, let's get right into the program. And it is an honor for me to introduce our first keynote speaker. So, starting with a successful career as a cardiovascular surgeon, she was selected to be an astronaut, thereby being the first Japanese woman in space and the first Japanese citizens to have 2 space flights. And she has received a plethora of awards for her work as an astronaut. And among her many assignments, she is the vice president of the Tokyo University of Science and also a senior advisor to the director general of the Japan Aerospace Exploration Agency, JAXA. So please welcome Dr. Chiaki Mukai.
Thank you very much. I think microphone is on, yeah? And then good afternoon, everybody. I'm Chiaki Mukai from Japan Aerospace Exploration Agency, JAXA. And it's my great honor to visit Stockholm to discuss about space with you in the occasion of the 50th anniversary of Swedish-Japanese good friendship, like we have with Krista, my colleague, astronaut, Swedish astronaut. So today, I'd like to discuss how science and technology in human space exploration improve people's lives. So given this opportunity, these are the topics that I would like to cover. The brief self-introduction about how I can involved in the space program, and then the main contest is the space for the Earth benefits. The example like a space satellite program followed by human space flight activities. And then I would like to also talk about the future, especially about the Japanese Space Agency is thinking, because future is ours and it's very important. So now, many people ask me, oh, Chiaki, to be an astronaut is your childhood dream? Actually, no. Because when I was a child, there's no space program in Japan. Of course, during that time, there are so many achievements in the world. Like when I was 9 years old, Yuri Gagarin, first human into space, flew into space. 2 years later, Tereshkova, first woman in space. When I was 11 years old, and then when I was a high school student, excitingly enough, actually 2 Apollo astronauts stepping on the moon. And then I was so excited, wow. But I always felt, oh, it was happening outside, somewhere outside of my life in Japan. So my first dream was to become a doctor because I wanted to help the people suffering from diseases. Especially my brother had a difficulty to walk, so that's the main reason why I wanted to be a doctor. And fortunately enough, I had become a medical doctor and specialized myself as a heart surgeon before joining to the space program. But you know that life is full of mysterious things included. Nobody knows what's happening in your future. Back in 1983, when I actually finished my chief residency in heart surgery division, suddenly Japanese government announced, we need Japanese to go to space. Wow, that's wonderful. And then it said, we need scientists, teachers, medical doctors, anybody who does some technology issue, because we utilize space environment, which is basically microgravity environment for research purpose. So no pilots, but we need scientists. Then it made me I was so impressed. Wow, 20th century was advanced in a way that ordinary people like me working on the Earth could expand our activities into space. That's the reason why I just get interested in space flight. And I wondered, what if I could see our home planet from space? It would maybe deepen my way of thinking, expand my way of thinking. So that's why I applied. And then, fortunately enough, I was actually selected as the first group of Japanese astronauts. So 1994, first flight with the science the mission, the international microgravity, the second, 50% of payload came from Europe, actually. We had almost 100 experiments on board, 2 weeks mission. And then 1998, this is also a famous mission because I flew with Senator John Glenn. And then Senator John Glenn, when he was 7 years old, we wanted to investigate if aging process is almost the same as some degradation, the situation happening on the healthy astronaut in the microgravity environment. So that's why it requires intensive medical knowledge. So I was selected on this mission and flew. So the 2 missions. And later, when I came back, 2007, I established the Space Biomedical Research Office in JAXA, our agency, to support the human exploration. So our office had the physiological countermeasures, development and cosmic radiation, and the environment of spacecraft like of gases and microorganisms to investigate. Psychological support is very important, and medical systems is a telemedicine type of thing that we have investigated or researched on. And also I established a moon-based frontier medicine at that time, especially targeting on the partial gravity, because Moon is 16G, so based on the microgravity research, we would be able to investigate the G threshold, gravitational stimulation threshold related to the living organisms. And also, if it's the small enough, the 1/6 is not good enough, we may need artificial gravity on the Moon surface. But we don't know how much gravity we need. That is a very interesting question. And regolith, that's moon dust affecting on our maybe lung system. And radiation is a big issue. So there are so many things that we need to research on before sending the human beings onto Moon or Mars. So this is what I have done so far. And then I'm very much interested in the science use in space as well as the education. That's why currently I work as the Vice President of Tokyo University of Science to promote the education for space and research. So going into the second topics. Now, the space for the Earth benefit. Quite a lot of Earth benefit we have. But actually, if I talk about the space benefit on the Earth, maybe introducing the SDGs, which is defined by the United Nations, the Sustainable Developmental Goal, will be a very good idea. So this is a space medicine as an example. Space medicine will contribute to create a better society. Because originally, space medicine is for the people flying into space, for the Moon, to the Mars, etc. But at the same time, quite a lot of things is happening, helping on the Earth-based medicine. I will explain it later so that we combine this space medicine issue for the United Nations Sustainable Development Goal. So what is the SDGs? This is a set of 17 goals, the Sustainable Developmental Goals to end poverty, protect the planet, and ensure prosperity for all as part of a new sustainable development. And the catchphrase is nobody left behind. So SDGs works as a good reference to think space benefits to Earth. So that's why our agency uses this goal as a reference. And then, why SDGs for space? Japan is home to extensive space development. We study the origin and the evolution of the solar system. We launch vehicles and satellites. We assign astronauts to perform missions on the International Space Station, and we analyze data obtained from missions and satellites for people on the Earth. It is interesting to see how such extensive space activities contribute to SDGs, Sustainable Development Goals. So this is just an example, flood, damage mitigation. This is one of the greatest benefits derived from Earth observations. The mitigation measures contribute to the achievement SDG 6, clean water and sanitation, and SDG 11, sustainable cities and communities, reducing the number of deaths caused by disasters. Monitoring and warning systems have been implemented in the region to prevent flooding, which combine satellite-based global preparation data, such as the Global Satellite Mapping of Precipitation, GSMAP, produced by JAXA, our agency, and the data set with ground observations. The warning system operates in collaboration with the International Center for Weather Hazard Risk Management, UNESCO, Asian Development Bank, and the governments of Pakistan, Bangladesh, Vietnam, and the Philippines, because our satellites covers Asian area more than the European area. The frequent updates to the data and warning systems allow communities longer evacuation times, and flood forecast enables crop harvesting prior to extreme weather events. This is one example. Other example is protect our health from air pollution. This is also very important. This contribution to achieve SDG 3, good health and well-being, SDG 11, sustainable cities and communities, and SDG 12, responsible consumption and production. Fine particle matter concentrations over cities are estimated by numerical models integrating satellite data and in situ data. Aerosol data from the geostationary satellite Himawari 8, which is our agency's weather forecast the satellite, are available every 10 minutes with 5-kilometer ground resolution. With the ASEAN Specialized Meteorological Center, JAXA estimate the timing, place, and the around of the haze migration, and alerts are sent out to local citizens. These data are critical for policy decision making on air quality management in urban areas, as well as for estimating population-weighted exposures and health outcome. The other example is monitoring tropical forest is to reduce emissions from deforestation and forest degradation, contribute to SDG 15. JAXA provides global SAR, mosaic, and forest, non-forest maps with 25-meter resolution. JAXA has released these products for free under the scheme JJ First, which is a collaboration with Japan International Cooperation Agency to provide authoritarians and governments lodging area information analyzed by Earth observation satellite ALOS-2, Advanced Land Observation Satellite number 2, which is our JAXA's big Earth observation satellite. And moreover, information is accessible to anyone with computers or mobile device. JAXA plans to provide annual global forest, non-forest maps to help the community better understand forest distributions. That's how also we do. And then getting closer to the health, this is the JAXA joint work with WHO in polio eradication. This is the SDG 3 contribution. Polio still threatens the lives of many in developing countries where hygiene sewage systems are underdeveloped. The status of propagation, reinfection, and efficacy of countermeasures treatment can be monitored by detecting the polio virus from water samples in sewage. Since epidemic areas are widely distributed and located in remote areas, WHO needs to narrow down their locations to collect water samples. JAXA provides a 3D view of the Earth using both a digital elevation model and AEROS images, satellite images. This technology is currently being tested in Nigeria. Catchment area, flow path, and pour points are investigated as possible sampling locations. And the WHO considers this analysis, thanks to the space asset, to be a very useful tool, especially in complicated landforms. Now, ISS, which Swedish, the colleague, Krista flew on. So this is the International Space Station. So the essentially, International Space Station is a satellite with human beings are living in. So the International Space Station offers us the new knowledge of and approaches to science education and technology and medical support. Thus, it contributes SDG 3 and 4 mainly. Now, going back to the space medicine is a preventive medicine. Prevention is everything. Much less medical costs compared to extreme treatment. So, it will contribute to create a better society by helping people not to become diseases, by educating people on a healthy lifestyle, and by promoting welfare. Many spin-offs from space medicine and life science research can be expected to dedicate SDGs. Now, the interesting enough, space environment gives us a unique opportunity for understand the human body. For example, phenomena augmented in space. In case of decrease of bone density, that you can take out this slide, the average loss of bone density in astronaut living in space for 6 months is 9%. On the other hand, menopausal women living on Earth usually lose bone density at a rate of only about 1 to 2% per year. This is more than 10 times greater loss in bone density observed in space, even the young astronaut, compared to that of the menopausal women on Earth. Now, muscle atrophy in space, 2 times more than in the case of bedridden subjects, like a bed rest study subjects on Earth. It seems like space environment accelerates aging process. So solutions and countermeasures for the problems in space could be more effective on Earth. This is the world population aging 2015. Left column, age 60 years over, increasing. The right side, 80 years or over, again, increasing. We are heading towards the aging society. So I believe space medicine as a preventive medicine can contribute to solution for aging society. So this is a very busy slide, but basically this summarizes what we have done so far. Like left column explains about the preventive medicine in space, such as physiological countermeasures, psychological support, telemedicine, space food, development in nutrition, and healthcare. If you take a look at the right one, the right column explains about the application. So the application of the space medicine to life on Earth. So this area includes preventive medicine, mental health, medical care, food safety, occupational medicine, and so on. Now, in conclusion, the space activities contribute to SDGs, Sustainable Development Goals, in many ways. Any space-related issues which living organisms, including human beings, are involved, then we can always expect the Earth benefits from space. Now, going to the future, my third topics. So this is the current situation of Japan. Now, if you take a look at the first one, post-ISS, International Space Station celebrates its 20 years anniversary this year. So now we have talked about the post-ISS plan and a new concept of human space exploration introduced by ESA, like Moon Village, UAE, China, etc., many countries. And third global exploration roadmap issued January 2018, and the ISS partners discussed about the Lunar Orbital Platform Gateway, LOPG, and JAXA, Japan hosted the second International Space Exploration Forum. It's a very big high-level forum this March. So I believe new era on human space exploration from LEO, which means low Earth orbit, where International Space Station reside, to Moon or Mars started. So now, again, we are living in a very exciting time. So this is JAXA's Exploration Center. We have just established July 1st, 2018, this year. So it is manages and coordinating all JAXA activities related to international space exploration. Scope is till Moon and Mars, not to the asteroid like Hayabusa 2 arrived yet, but Moon, including Lunar Orbital Platform Gateway, and Mars. So this is the organizational chart. What I would you to take a look at is the center. The red part is JAXA Space Exploration Center, and it has a full support from all JAXA. Like green part explains about the JAXA's activity, Human Space Technology Directorate, and the Research Development Directorate also supported. Institute of Space and Aerospace Science is a basic cosmic science institute also supports. And then the Space Exploration Innovation Hub also supports this exploration center. And under this Space Exploration Innovation Hub, we have a lot of the Japanese industries, the corporation are belonging to. Now, not only the JAXA, but also academia approach. I am currently work as a vice president of Tokyo University of Science, and this university has established the research center for space colony, targeting for moon base. And then our idea is developing technology for moon base habitation and its application to the Earth society. So we would like to utilize the state-of-the-art Earth technology coordinating into the moon base, utilizing on the moon base, and then bring the core technologies such as photocatalysis, sensor technology, IoT technology, battery or energy technology, bring back to the Earth. So this research center, we have selected 3 areas. The living in space needs energy supply. So we chose energy division and also recycling of water and air division. and food production for self-support. Of course, it takes only 3 days to go to Mars, so you can have supply from Earth. But the self-sufficient way is the way that we want to develop. So this is my last slide. So far, I have talked about the material and tangible benefits from space. At the same time, space gives us intangible, non-material benefit. Although it cannot convert money-wise profit, I believe that it is, which is an intangible benefit from space, is very important. Because I would like to say the 3 points explaining about why it is important. Because intangible benefit teaches us resource is very limited. If you take a look at the picture, you can see whole Earth. This is a place that we can live. We utilize resource in a limited way. So by watching from space, our home planet is magnificent, beautiful, and giving us its natural resources for diverse living organisms on the Earth. By watching from space, at the same time, we have realized that its natural resources, including air and water, is limited. Our Earth is fragile. We must think about the better use of the limited resources and work internationally to sustain our precious resource. That is the number one issue that intangible benefit gives us. And the second part is objective way of seeing our world. If you take a look at this picture, actually this was taken by our satellite Kaguya, but I was always impressed that the 12 people, Apollo astronaut landing on the moon, who saw this view from the moon. So look at where you are from the outside of your world. You will be able to understand the bigger picture to solve the problems you may encounter. So objectively, you think about the situation. Everybody think the place where you are is the center. Egocentric, I'm the center, Earth is the center, or this organization is the center. But if you just change the perspective from the viewpoint, the other side is also thinking. They're also the center. So this is the way that we can relatively take a look at the view of the place. That is the second part that I believe that the intangible benefit gave us. The third one, that's the last one, and then the acceptance of diversity. No border on Earth, at the same time, no border in space. Space is too big to explore by one nation, one organization, and one company. Thus, we need good cooperation among diverse groups to enhance our strength. So let's learn from the differences and cherish similarities. Space can unite diverse people for the sake of humanity, I believe. So thank you for your attention.
Thank you very much, Dr. Mukai. If you would like to stay, do we have any questions to Dr. Mukai? How has, when I visit another country, I always get new perspectives on my own country. How has the perspective of being in space affected you personally? What kind of new perspectives have you got?
Well, you know that the reason why I wanted to be astronaut was expand my way of thinking, something like that. But situation is thanks to the training that we have done, like even during the training we work together internationally, so it expanded my idea. But of course, view from the space, Earth is so beautiful, and I was so proud that I was a part of that beautiful planet as my hometown. So it gave me a lot of sense that we have to work very good on the good Earth living people.
Mm. So you mentioned the moon base project, and we are of course excited to know when will we have a base on the moon, you think? How long will it take?
Well, how long does it take? It depends on the how we feel that we want to promote the situation. Tomorrow I will have a presentation in KTH, and I will explain a little bit about the science on the moon base. But the reason why the moon base, the habitation, the research, habitation research works in a way that even if we don't go to the moon yet, we are targeting on the moon base, then bringing the good science result, which maybe work on the moon, will have a lot of spin-offs actually on the ground. Then more people are involved in the space program, and more people involved in more budget, and then it's accelerate to go to the moon over Mars. So it depends on we and you.
So any question? Yes?
Yeah, thank you. Very exciting.
Oh, I think you...
I want to ask you about bone marrow. It sounds terrible that you astronauts are losing a lot of bone matrix while you're in the space. But are there any benefit for normal body to be in the space, or just bad?
Well, basically, from the viewpoint of life science, our body is formed in a way which is fit to the Earth environment. So if you just go to the outside of the Earth, something happens. But if I can just find out the good way of utilizing microgravity, of shaping my body, is anything I want to up, like a bust up or hip up or anything, or maybe face up. And, because there's no gravity, I feel like, oh, I become younger.
Thank you very much.
So any further questions? Well, thank you for now, Dr. Mukai. We'll come back in a little moment for the Q&A session. Thank you very much. A round of applause. And I would now like to introduce our second keynote speaker. He's a particle physicist and was a fellow at CERN working on the Large Hadron Collider project before being selected to be an European Astronaut Corps in 1992. So he is the first Swedish citizen to have been in space, and the first person outside the United States or the Russian space programs to have participated in more than 3 spacewalks. So now he's a professor in space travel and director of the KTH Space Center at the Royal Institute of Technology in Stockholm. So please welcome Christer Fuglesang.
Thank you. Thank you very much, and I'm very glad for this opportunity to talk more about space and science and how we use that to inspire. See here if it gets going. Do I need to do something else here? It's Robert there. There. Well, okay, we can jump to this one. So, as was mentioned, in 1992, I was selected as an astronaut for European Space Agency. And after spent 1 year in Germany and then 3 years in Russia, in 1996, I came to Houston, Texas, to join the largest astronaut class NASA's ever had. Became so crowded, so we got the name of the Sardines. But I was there in 96, or a little bit later, I first met Chiaki, who flew in 98 and said together with, let's see if I can get this here, together with one of my colleagues there, Pedro Duque from Spain. So he was one of my first and still best astronaut colleagues and friends, and actually now he's the Minister of Science in Spain. Here I also met two Japanese astronauts, Suichi Noguchi there and Mamoru Mori there. And it was why Space eventually came to Japan in 2008, invited there by then Swedish ambassador Stefan Norén, who actually now is working a lot with this celebration of the Japan-Sweden 150 years of friendship, as you mentioned. It has also been behind part of this meeting here. Well, it took some other years. This was 1996, but it took another 10 years before I finally was on my way to space. And I want to first show you space travel, and then we talk more about space science. So this is in December 2006, 14 years after I became an astronaut, and finally I'm sitting there. The engine gets going, and when the booster ignites, you know you go somewhere, hopefully all the way to space. It's a powerful event. It's pretty shaky. Should have a little bit more sound, you can really hear it. Shaky, both physically and psychologically. But I was just happy, laughing near my spacesuit, finding my way to space. The space shuttle weighed about 2,000 tons when it took off. And you can kind of say that it needed about 50 million horsepower getting it up to speed. But you can point out someone brags about this new car with a few hundred horsepower. Unfortunately, though, the space shuttle was a bit dangerous. It had 2 complete catastrophes and 135 launches. It was quite expensive. So in 2011, it was retired. But it was an amazing ride, particularly the launch. After 2 minutes, these boosters decouple, and then it became a little bit less shaky. But the acceleration increases, and last minute you have about 3 G's acceleration. You really get pushed down in your seat, weigh 3 times more than normal. But then in split second, only 8.5 minutes after takeoff, the engine stops. You feel thrown forward in your seat, but actually unbuckle, and you're just in weightlessness, a completely new way of life. 2 days after launch, we docked with this International Space Station, which at the time was pretty much halfway built. And our main task was to continue building the space station, which we did already the following day during the first spacewalk. So we had a piece with us up in the shuttle, that one here, which was brought by robotic arms out to the end of the space station that it was at the time, and we prepared it, worked on it with this kind of battery-driven bolt drivers, and secured it in place. The following day, we were going to retract solar arrays with commands from the inside, and this is a huge thing, it's about 30 meters long. But it didn't go as planned. It didn't want to fold properly here. And that became a problem which the ground control had to try to figure out how it could be solved. And in the meantime, we continued up there with what we had trained and planned for several years. Here's spacewalk number 2. Among other things, we reconnected the electrical systems. You can see we had cameras with us even during the spacewalks. There's an airlock here working outside it. That's a Soyuz capsule which the crew which were there had with them as also the kind of safety boat. And it's always nice to talk to your friends, what you're doing. Or at least coincidences. And I took a chance to do a little frisbee trick, which I didn't want to acknowledge as a world record. I thought it was cheating doing it weightlessness. Pity. And then we got a call from ground, said, hey guys, you better go out and do another spacewalk to fix these solar arrays. And that was a real fun challenge because we had not trained for that. We didn't know how to do it when we started, but with the help of the real smart guys in the Mission Control Center, we found solutions. It eventually worked out, and everyone was happy, and we could leave the space station. Here, by the way, you can see it's empty in the payload bay of the shuttle. That's where we had brought with us this piece to the station up. We still had a couple of things to do in space, though. This was a few experiments which were deployed from the shuttle. That one, for example, was going to study the remainder of gases, or rather just atoms. So it's still up there on several 100 kilometers altitude.
Main gear touchdown.
And 13 days after we left Florida, we are back there in the sunset 2 days before Christmas Eve. Our commander did a perfect touchdown. It's good he could do that because the shuttle, when it came in for landing, was actually like a glider plane, and a very clumsy such. You only have one chance to land, no engines then to kind of try again. But it went well. The whole trip was a fabulous trip to experience the weightlessness, to see the wonderful views, and best of all, the spacewalks. This photo was taken by our commander from the shuttle during the first spacewalk, and it actually ended up on a website for travels with, called the Travel Picture of the Year 2006. I didn't invent that. And the funny thing is that someone in the comments lower had written, "Oh no, that's obvious fake, photoshopping, just too good to be true." But like I say, I was there, so I know it's true. What you see here is, by the way, New Zealand, the South Island and the North Island. Well, I got a second chance to fly about 2.5 years later. Here I'm on my way with a new crew to the shuttle. And this is how that launch looked like. And it was exactly midnight local time. So down there was the 28th of August 2009, and over there a few minutes later, the 29th of August. And it's not that we go up and crash down, but it's that we go up beyond the atmosphere. So there's no more air resistance, such that we can obtain the speed we need, about 28,000 kilometers per hour, to go into orbit and not fall down. And as you all know, the Earth is round, so we're kind of following the Earth. That's what you can see there. Also, that mission went to the International Space Station to kind of did some final work to finish it. And this is how it looked like when I left it in 2009. And it's a little bit more there now, but not much more. And it's really an amazing thing which has been built there in space, like a super Lego. About 350, now 400 kilometers above Earth. That part was first one launched already in 1998, and 2 years later it was big enough to be permanently crew, which has been now for almost 18 years. And it's big. It's about a little bit over 100 meters here, and that's about 80 meters. So we built this space station for several reasons. We want to learn how it is to build and live and work in space, things we need to know before we go further in space. But space also offers unique opportunities for science. Science in many very aspects. You can study space from there, looking upwards. You can study the Earth, looking downward. And you can utilize the weightlessness, and that's particularly what's done inside the International Space Station. But first of all, I want to show this with the Earth, and which Chiaki talked a lot about, how fragile our atmosphere is. Here is a sunset. By the way, you get, or maybe sunrise, hard to know, but you get 16 of these each day, so you don't have to wait long before you can take such a photo. But here's the black Earth, the black space. You can see the rudder of the shuttle. That's our whole atmosphere, roughly speaking 100 kilometers. But it's only the 5% closest to Earth, 5 kilometers. We have enough oxygen for us humans to live without a spacesuit or spaceship. And the whole Earth is basically the spaceship for all humanity. And we have to take care of our environment here. We were very careful with the environment on the space shuttle. We wouldn't have a long time there if something went bad. We have a little bit more time on Earth, but we cannot mess up too much. And really, that's one of the many sciences from space. Learn about the Earth. And I think we learn more about the climate problems from data from space than from what we gathered on Earth. Now, though, weightlessness is probably the area where we do most kind of science inside the space station. And it's because things behave differently in weightlessness, and you can study phenomena in new ways, and we learn new things. For example, in physics, biology, medicine, here you don't get convection. Warm air is lighter than cold air, so therefore you get an airflow going up, and then you get new air coming in, you get a convection when you burn something on Earth. While in weightlessness, it doesn't matter that the warm air is lighter, it doesn't go any particular direction. So it looks like that. And yeah, you can dance in space. So you get rid of convection. You can study, for example, combustions in new ways. How do things grow? Roots, how do they know they're going to go downwards? Well, in weightlessness, they go any direction. You can study the sensitivity of it. And humans is maybe what we study most up there. I'll come back to that. Another thing is you can do experiments which are hard to do on Earth. You know, if you're good in mathematics and mechanics, you can do the math. You can figure out that tweezer would flip around like that and spin. But it's very hard to do that. You can experiment on Earth, and often when you're done, you have a model, you do calculations, you want to prove it. And some experiments are hard to do on Earth. You can kind of then do it in weightlessness. That was a simple example. We also do things on the outside. And one of the more exciting things, I think, is that we have put living organisms on the outside on the space station and also other spaceships. And then they have been exposed to the vacuum, to the radiation, to the changes in temperatures. They go into hibernation, some of them, come back to Earth, even after half year up there, and they kind of start to multiply again, get back to life. And even small animals, like that one, is a tardigrade, Björndjur in Swedish. It's actually from Öland in Sweden. That was not on space station, but on another spaceship. But this is not only, wow, cool, but it also gives credibility to this so-called panspermia hypothesis that life may not have originated on Earth, that could have come from somewhere else in space. Or another consequence is that when we send now spaceships to Mars to look for life there, we have to be very careful that what we find on Mars is not something which we brought there ourselves. Even on the outside of our spaceships, it could survive. Going back then to humans inside, and astronauts are really guinea pigs up there because we need to learn what's happening to our bodies in weightlessness, which Chiaki talked so much of. And most of the effects are really negative, and I don't need to repeat what Chiaki said, but therefore there are experiments being done on astronauts almost daily on the space station. And we learn not only how we can find countermeasures, but what we need to know in the future. We also can help people with this new knowledge. By the way, someone asked, any good effect going to space for humans? Yeah, you look younger. Look at me there. Just before launch, I'm getting a bit old. And a day later, I'm in space, and you see all the wrinkles goes away due to the fluid shift. The fluids here are pressed down in our legs, pulled down by the weight, but in space you don't have it, so it comes up and you get fluffy in your face. It goes away as soon as you come back, though, unfortunately. On the other hand, you can feel a bit fluffy, like a cold in your face. It's not only good. But that's a lot of things happens to our bodies in space. Another thing which happens is that your balance systems doesn't get signals the normal way. So your balance systems kind of get untrained, and you come back to Earth even after 2 weeks. You stand up and you're unbalanced, and it takes some days to recover. And I was part of a series of experiments which was studying how the balance system recovers. And it wasn't too fun to do this experiment, I can tell you, particularly not just after landing. But what don't you do for science? And indeed, due to these and similar experiments, scientists have learned new things how our balance system works, which now can help people who have clinical balance problems. Well, another problem in space for humans is radiation, particles in space. Some of them come from galaxies, some of them come from the sun, and in particular can be bad if the sun has its eruptions. And this is something which I've been kind of part of studying myself. So fortunately we have a magnetic field around the Earth which can protect us fairly well on Earth. And on ISS, we're also somewhat protected, but going to the moon, this can get really bad. And I want to show you something which happened to me during my first space flight. So what you see here, this is data from a kind of called satellite, which is between the Earth and the Sun, which measures the flux of particles coming from the Sun. And when I say particles now, it's mainly protons, some electrons, some heavier nuclei. And logarithmic scale the flux in 3 different energy bands, and there are more of them with lower energy than higher energy. And this is how it typically looks like. And this is days in December when we were on ISS. Here's normal here, and then suddenly it's one of these eruptions goes up a factor of 1,000 the flight. That is our first spacewalk, and towards the end of it, it happened, and the ground control who got this data, when they saw it, they was thinking of actually cutting our EVA short to tell us to go inside. On the other hand, we were towards the end, so they didn't care. But that night, they told us, you're not allowed to sleep anywhere you want tonight. You need to sleep in some of the places that are more covered. Now, then it kind of exponentially decayed, this shower, and down to basic level again. We go out for a second spacewalk, and in the middle of that, we have another shot coming from the sun. It was almost someone wanted to shoot us. Now, normally you don't see this, of course, but we measure it all the time. But there's some way you can actually see these particles. For astronauts, most of them, when you close your eye, and if you don't fall asleep too fast, then you can suddenly see flashes in your eyes. And that is from these particles, typically protons or atom nuclei, who interacts in your retina. And I've been part of a research project to kind of study this a little bit more and try to understand it, and also we've been simulating how big is the flux of particles on the space station. And one of the experiments I took part of was called Altea, which really was the name of the Italian scientist's daughter, but of course then he came up with an acronym for it also, anomalous long-term effects in astronauts. But the idea was that we had this detector which was tracking particles which came from space, from outside, going through the walls, and then through this detector you can track it and see if it hit your eye. And then at the same time, someone was there inside, and when you saw a light flash, you pushed the button and it tried to correlate it. I did that experiment during my first flight, and I spent about 90 minutes there looking for light flashes. In the meantime, all the others, they were kind of going back here with a lot of stuff which had to go back and forth between the station and the shuttle, and they thought I was cheating out from the real work. When I was doing the real work, I was doing science, right? But also with the same, not only that, we also took EEG, brain kind of wave data. So unfortunately, the statistics are low. You only see one every 7 minutes on average. But we have learned a little bit more on how these light flashes works, and one of the things that they work in the retina. So I'm back at KTH since 5 years, and now I'm still studying particles from space, but now the highest energetic particles. So what you see here is, as a function of energy, logarithmic scale, the energy of the particle. And to give you an idea, if you're not used to this units here, 1 GeV, that's here, 10 to the 9 eV. That's the energy, the mass energy of a proton. So if you tell you maybe something. And here you have the flux, and you see the order of 10 to the 4 here and 10 to the minus 28 here. So these particles over here are extremely rare, but extremely interesting, because they have as much energy as a kind of tennis ball coming from a hard smash, and it's a proton or a nuclei. It's incredible how such a small particle can have so much kinetic energy. But they are very unusual. They're about 1 particle per square kilometer per year, and down here is about 1 per century. So the way to observe them is that they interact very high up in the atmosphere when this hits some of the molecules or nuclei in the atmosphere very high up. And then they sort of cascade of particles. And this cascade eventually kind of shake the nitrogen in the atmosphere, which sends out fluorescent light in the UV spectra. It's somewhat similar to aurora, actually. And the idea is that if you're in space and you look down, you can see very much larger area instantaneously than you can if you just put these detectors from ground. So that is the plan. This experiment is called Extreme Universe Space Observatory. We want to put it on the International Space Station. some time and learn more about these very unusual particles. Now, though, unfortunately, we don't have the money yet. We're working on it. But in the meantime, we are doing what scientists typically do. You do pathfinders. We are putting these kind of detectors to learn the technology and do studies what we can, both in ground, on balloons, and in space. And indeed, we will put the next year a small detector called Mini-USO. And I've been working particularly with that one. It goes to ISS next year to test the technology, but it's also studying the UV light on Earth, very sensitive in a new way, so we can do a lot of other science with it, which is typical. You build a detector, but you can use this to a lot of various science. So you can make a map of UV light from Earth. We study atmospheric phenomena, very high altitude flashes, meteors. Well, that's something which people don't believe exists, strange quark matter, but we can at least set a new limit, how unusual it could be. Bioluminescence. So that is a small detector, it's about 60 centimeters, and that's my PhD student testing it at the roof in Japan, by the way, Riken, outside Tokyo, because Japan is one of the bigger collaborators in this experiment. And then it will go to ISS next year, and we put inside through and look through a UV transparent window there, the Russian side. Actually, the biggest experiment we have on ISS is also an experiment to study particles from space. The AMS, the Alpha Magnetic Spectrometer, which is 7 tons, which is really big for experiment in space. It's nothing compared to what you have on CERN, where they're about 25 meters by 40 meters. But it's actually kind of a mini detector of that kind you have on CERN. To study what kind of particle is going through this detector here. And you have a lot of different kind of detectors, including a magnet to figure out what kind of particle is it and what's the energy. And to learn more about the universe. And the highest prize for them, so to say, that is if they can find some signs of the dark matter. We know there's much more dark matter in the universe than there's normal matter, because we see how stars and galaxies move around each other, so we can figure out the gravitational forces there. And the gravitational force is much bigger than what we can get from just looking at the stars, the light. So that's what's called the dark matter. And we think it's a kind of particle. It might be this one here, the neutralino. This is the soft version of a neutralino. It flew in space, so that one's been in space. As a member on the shuttle crew, you were allowed to bring with you a few mementos from organizations, schools, universities. So I asked CERN, since I'd worked there, if they wanted to send something. And they came up with this one. It was a great idea, I think. Here you see both the logo of CERN and the logo of ESA. And at CERN, they're also trying to find these particles. But there they try to create it in the big collisions and see anything. But so far, no one's seen it. It's a very fluent guy, so we don't know if it's there yet. Now, of course, we do a lot of science in space, not only on ISS. There's a lot of satellites up there, or spacecrafts gone to other planets and all. And maybe the most famous of all, the Hubble Space Telescope, which, by the way, also was tended by several astronauts, colleagues who went there with the shuttle. And it's taking these beautiful pictures of nebulous or galaxies far away. But this one, studies from this one, and now together with others like this is the European Planck satellite, who studied the cosmic microwave background. And these things together had learned something even more strange than the dark matter. It's like most of what is in the universe is, we don't know what it is. Best estimate today is 68% of the energy. And energy matter, as you know from Einstein's famous formula, E equals mc squared, they go together. 68% is this dark energy. And I was figured out through, first time through, that with the Hubble Space Telescope, they studied galaxies very far away, special types of galaxies, and you see what's the speed they they leave us from, how the universe is expanding. And from seeing that, about half age of the universe, which is 13.8 billion years old, half time to that, the expansion rates increased. And the best kind of explanation one come up with is that it must be something called dark energy, but we have actually no clue what it is. So you see, only about 5% we know what it is of the universe. A little bit embarrassing. But we continue working on it. Now, you don't have to go to space for a long time to do research in space. Before I go further, I want to tell you what you see here. So this is an alloy which is solidifying, and it's been filmed by an X-ray camera. If you do it on ground, due to density differences, you see things breaks off and floats up. If you do it in weightlessness, it doesn't matter. It doesn't get disturbed by the density difference. So in this case, you can study the nucleation process much better than on the ground. You can learn new things which you can then apply into processes to create either new materials or improve the materials you have. And that kind of experiments actually led till, among other things here, you can make more lightweight parts to aircraft engines to save fuel. That one was actually filmed by a camera on this rocket. And I think that was built by the Swedish Space Corporation, by the way, the camera itself. And we have these sounding rockets up in northern Sweden, S-range. And you can do weightlessness up to 13 minutes, the most powerful rockets you can launch from there. And that's been something we've done for 50 years. So you can also do science in space from Sweden. Now, we hope to improve that a bit, quite a lot in the future, by being able to launch even bigger rockets from S-range, so we can put satellites into space from S-range, which would be a huge step forward for Swedish space activities. We're just waiting to get the money. Where's Magnus here? So, going back to a bit ISS and what we do there. So one of the things, as I said, was that we also do the science to learn to live longer in space. And it's a lot about learning to do reutilization, conserve resources, and things like growing food. So first lettuce crop up there for future space flights going further. And basically, if you just have enough clean energy, you can do everything. I mean, today we're about 90% recycling water. You have, I don't know, maybe 30–40% sometimes of recycling of carbon dioxide, which is 6A. So far, no recycling of the other waste we have from humans. But we're working on that, testing it out here in low Earth orbit, all the things which we need to know when you go further, when it's more expensive to send resources, logistics further away. And as Chiaki mentioned, we are working now to go back to the moon. And the first step will be to build this deep space gateway. And finally, after many years of Obama saying we cannot go to the US will not go to the moon, now even NASA can say, okay, let's talk together about going to the moon. And the first thing plan is to build a small space station around the moon on an orbit which is very far from the moon. It will be temporarily manned or crewed in the beginning. From there, then will be make sorties down to the surface of the moon, and then eventually we will build some kind of moon base. Let's call it moon village. You know, no one has been on the moon since this photo was taken. It's a shame. We need to go back. Actually, right now there's 2 planned mission to go send people around the moon in 2023. It's NASA who's building a new big rocket with a big or bigger Apollo kind of thing called Orion, and they will fly unmanned 2021 around the moon, and 2023 they say to have the first flight around the moon with humans. At the same time, recently Elon Musk announced that SpaceX, his space company, building a new big rocket, which they say they're going to send the first humans around the moon with in also 2023. A Japanese billionaire has bought that flight. Again, Japan, you're very... exactly. So we'll see. But the interesting thing is there's many players now, as kind of Chiaki said. And we need to go there to learn so many things before we go to Mars. Take a few days to the moon. It takes at least half a year with today's technology to Mars, one way. And one of the most important things, that is to learn how to use utilities you have there, which we call in situ resource utilization, which is also kind of science. But it's maybe not so science so much for the Earth in this case. It's really for the science which you need to be able to move out and not have to send so much there. You can use it. So recently, one has found that it seems there's quite a lot of water even on the moon. Not floating, but ice in the soil, in the regolith. And if you can learn how to utilize it, you can make oxygen for humans, you can make water to drink, you can make propellants for spacecraft. And because of the much less gravity on the moon, it would be very efficient to then make the propellant on the lunar surface, bring it up to the deep space gateway. You can use it like a gas station for the spaceship then going to Mars. And eventually we'll go to Mars. And I hope we eventually will do something there. Now, I don't know how much time I have left, but we also talk about inspiration. And it's kind of, a lot of this is for inspiration. And I think it's one of the most important ways within. Just seeing your own home from space, for example, that's where now it's very inspiring. This is from the ISS, although I didn't take it myself. It was taken a couple of years ago. Great photo. And you even have an aurora there. And this is something which we astronauts do all the time. And it's very easy to inspire people what you can do in space and with space if you can show them videos like this. Which, by the way, shows also a little bit of science in space. You see, this is fluid science, right? You can do definitely a lot of fluid science, which you cannot do in Earth. Then you can see more physics here, the adhesion effects. You can simulate orbital mechanics and submarines in weightlessness. And when you do that, then you can go into medical experiment, see if you can eat it. Or you can also say you're going to simulate a black hole, which is kind of taking a planet into it. So with that, you show that to anybody, they get inspired by space. And going out into schools and talk to children of all ages, that's something every astronaut do a lot everywhere. I do it quite a lot in Sweden with the help of Rymdstyrelsen, Swedish National Space Agency. And here was one of the visits. You see, often they have prepared, they build a solar system up here. And I actually written a couple of children books to try to also get them interested and inspired. Or older students, we have students at KTH which are building a satellite, CubeSat, where they are kind of putting these things together under the professional leadership of Sven Gran, who was the CTO of SSC many years. And by now, we're about 100 students who've been kind of working typically one semester each to get this together, which we hope to launch in maybe a year and a half. So I will just finish up. Space is for science, exploration, and inspiration, and it really helps us here on Earth. Well, thank you.
Thank you. So, do we have any questions from the audience? So I would like to ask, oh, sorry, one question there.
Yeah, I wonder about this USO equipment. How large will it be? Do you know?
Did you say when or how or big?
How the mass and the how large?
How large it will be? Order of 1 ton. It's kind of depending on how much we can get a little bit money, but that kind of order.
So how will it be lifted up to the ISS?
The current plan is that it will be launched with a Dragon, the SpaceX cargo vehicle to the ISS. But we don't have a deal with them yet, or with NASA to kind of do it. But that's what it's designed for, or being designed for.
Mm-hmm. We have another question over there.
Václav Gudovsky, KTH. Krister, two short questions. For the first, we humans are pretty effective on putting garbage everywhere, to water, to soil. This is an issue also with the space. How serious is the issue of the garbage in space, and what we can do about that? And the other short question, do you think that the monopolization of the space, I mean not only state actors, but also SpaceX company and other, is good for the space exploration, or this is mainly the risk for the space exploration?
All right, so the last question is, I think it's good. The more players, the better it is, absolutely. And space tourism I didn't mention, but that's something which is coming also. So and that's kind of, so you get the commercial interest in sending people to space. And the first one was that about the space garbage. Yes, that is a concern, and it's increasing. And we need to increase the kind of monitoring of it, to have more and better monitoring. We need to have some kind of global space control system, if people agree on things. Ideally, maybe see if it's possible to actually get rid of some of it. That's a very big technical challenge, because it's not so hard to get a piece of garbage and kind of make it fall down, but because it's so spread out, and it costs a lot of propellant to go from one piece to another. That is the big difficulty there. But at least people are aware of it, and we're working on it. For example, the space station, if something is, everything smaller, or from 5 centimeters and bigger, is tracked from ground. And anything like that risks coming close to the space station make a maneuver. The problem is when you have 2 dead satellites, and you can't move them, and they collide, which happened some years ago. Then you get a lot more pieces.
Thank you very much. We will continue with the program, so I ask you to stay on stage, Krister.
Okay, all right.
And also I would like to, first of all, a round of applause for your presentation, of course.
Thank you.
And as I said, we will now continue with the next part of the program, so I would like to invite Dr. Mukai as well to the stage, with a little round of applause, perhaps. So we will now have a special Q&A session together with the Swedish Youth Astronomical Association. So I would also like to invite the chairman of the association to the stage, Måns Holmberg. Welcome. And you have how many members of the association?
So we have 3,700 members as of 2 days ago, I think.
Here in Sweden?
Yes.
Ranging from how many years of age?
From 6 to 25 years old.
Right. So your members have been invited to ask questions to our honorable astronauts, of which some have been selected to be asked here.
Yes.
So I give the word to you.
Thank you, Anders. So we have 30 of our members here today, and some of them would like to ask our 2 astronauts here some questions. So I will ask Niklas Örne, please.
Okay, so first of all, I want to thank you both for 2 very inspiring presentations. And then I would also like to ask you, as someone like me who dreams of going to space and becoming an astronaut, what is something I could do right now to help increase the chances of achieving that goal?
Oh yeah. Well, it's deep. Well, generally speaking, I think you should have some specialties, so that you can say, I can contribute with such and such. Like my case, medicine and life science. And then the second one, to me, he says the astronauts' work is as a teamwork. So rather than doing something by yourself, developing a team build, developing the team building situation is very good, and then maybe the language is one of them. Of course, it's English and Russian is right now the common language, and then the fourth one is maybe good health, whatever you want to do. So that's the 4 basic thing. But actually, I think if you just go to the government-led program, it totally depends on what your government or what my government wants to do. Like if you want to develop some hardware things, maybe engineering type astronaut will be welcomed. And then, but if you want to utilize the space for certain purpose, astronomer or teachers or a medical doctor or whatever will be more welcome. So it's totally depends. But as Krista mentioned, I also welcome the commercialized space flight coming. And then at that time, you will have diverse maybe activities expecting so that the more, I think, chances for young people to go to moon. Even if if my situation, I really want to go to moon.
Me too.
And the situation is maybe I will, because I have a medical doctor license and also have a flight experience, so I will be the attendance for the commercialized space flight to the moon. So that will be my next job.
So, Chris,
I agree.
add something?
No, I think that was a very good answer. That's bad.
Thank you very much. Then we have Alma.
Yes, given that your profession is very international, do you ever experience cultural clashes?
Well, not much, but certainly when you move around different countries, you realize that there are cultural differences. And I can give an example. When I moved to US, it was my fourth country, foreign country, after France, Germany, and Russia. And I think I subconsciously thought that, oh, how nice, I finally moved to somewhere where I know the language in advance, and I kind of, everyone's seen all the movies and TV shows of US, right? But then after a while, I realized, oh no, things were different. For example, during the astronaut training, people told me all the time, oh, great job, Chris. Wow, wonderful. Oh, yes, so good. First you thought, yes, I'm good. And then after a while you realize, no, I'm not that good. So that means that there is some subtle nuance in how they say it, which for an American, he or she could figure out if it's really good or not. But for me, then I got uncertain and insecure. Right? That's an example.
Dr. Mukai?
I mean, well, I think the easy thing is that when I go to the United States, everything takes a size. So if I go to lunch, wow, lunch is maybe twice or three times more. But I really wanted to not beat, but fight with the American astronauts. And then if they eat all of them, okay, I will eat all of them too. That's how I worked. But as I mentioned, diversity is the one to make our team strong. So if you just take a look at the other place, like for example, I'm different from Krista, you're different from somebody sitting next to you, so nobody is same. So the cultural difference is comes not only from the nationalities, but different professions, like a medical doctor has a different culture from the maybe engineer. The people working on the military has a different culture. So the culture based on the profession is very strong. But I think that should be, because if you want to pursue whatever you want to do, you need to have something that you can, this is me, this is my the dedication, and then the different people has, again, the same way. So that's how I welcome the diversity. So I haven't crushed any. But sometimes maybe I crush the other one, I guess, because everybody says, oh, Chiaki, Japanese lady is supposed to be very obedient, because at that time there was the movie, very famous movie, Shogun. And then Shogun has a very, very gentle lady, comes, and she does everything for the men, and then they said, oh, Chiaki is different. And then nowadays, Japanese ladies are totally different from the Shogun era. So that's why I crushed them, I guess.
Thank you very much. Adam, please. Adam Broström. Okay, we go on.
No,
Jakob.
No, wait.
Ah, perfect.
Just has to borrow a microphone.
Yeah, so I wonder, what is the coolest natural phenomenon you have seen from space?
The coolest
The
natural.
coolest natural phenomenon is in from space or in space?
From space.
From space. Well, I think probably auroras. You saw this kind of solar shots during my first flight. Was trying to shoot me outside. There was a lot of solar activity during those weeks, and that created really nice aurora effects. And then I had some when I was doing my spacewalks, as you could figure out there, and that was amazing to see that.
I mean, yeah, aurora, this small. So, wow, this is aurora, that's beautiful. That's what, because my flight was the very highest position that the shuttle could be, like 550. So this is very high, so we could see the southern light from the very distance, and this is this big. That was wonderful. And then, the coolest thing for me was unexpected situation happened. Well, this is a water dump. Well, in the shuttle time, we had a solar system, so we had enough water so that we needed to dump before going back to Earth. Which I didn't know. Well, maybe I should have learned somewhere, but I didn't. One day I wake up and then watched on the outside. It seems like there is a snow actually in space. Then, look, we have snow in space, and then it was a beautiful small water particles actually shining under the sunlight, and it was so beautiful. So that is a scene that since I have never expected and saw it in space snow, so it was the coolest thing that I saw in space.
Yes, thank you. Jakob, please.
I would like to start out thanking you both for 2 great presentations. And my question is, how did it feel seeing Earth for the first time in space, and did you ever get tired of it?
Me? Well, no, I am so proud of my home planet, and at the same time, I am proud of myself. Wow, I'm living such a beautiful place. Wow, I'm proud of myself, and also proud of the people who are sharing such a beautiful place with me. So I said, wow, hello, this is great. So I never get tired to see our home planet.
Yeah, I can agree. Never got tired.
Well, talking about seeing the Earth, it is very interesting. The situation happens like I flew with Pedro Duque from Spain, and then everybody really wants to. Earth is our home planet, but even we divide the home planet because the Pedro took the Sierra Nevada mountain in Spain area, and Chiaki, that's a beautiful mountain. Okay, no, I can show Mount Fuji, our Japanese beautiful mountain. So that's how.
That beats it.
Yeah, and everybody want to look at the place where you are from.
Yeah.
So, Christer, what was your first reaction when you saw Earth from space?
I don't really remember. I mean, it was beautiful, beautiful. You in the beginning, you have a very tight schedule what you need to do. Just after launch, getting into space, and then you had, suppose, at least on our flight, you had to go to bed within 5-6 hours, and there was a lot to do in there. So it wasn't much time to kind of relax looking outside. Of course, you did quickly, but I don't remember I had any particular kind of thought.
Okay, Hugo.
Yeah, I was wondering how difficult, both physically and mentally, it is to go into space, and if you think that ordinary people will be able to go to maybe even Mars or just outer space in the future.
Yeah, I mean, if you're not responsible for something on the spacecraft, you're just a passenger. You just have to be normal physical fitness, I would say. Depending on how then the spaceship is built, you need to be able to do more or less in case of emergency situations. You may need to get some training or not. So it's like going in an aircraft. If you go in a typical jumbo jet, I mean, you don't need to prepare anything, right? If you want to fly as in the back seat of a fighter jet, Gripen, for example, they will require that you maybe learn a few things, and you have to do a medical checkup, all that. So that is how it will be in the future as a tourist.
I mean,
well,
basically, I think I'm the ordinary people. So I needed to learn something that I need to fly space. But if you have a profession that you want to pursue, then you can do it. And then, of course, going to Mars. The biggest issue is like Krista mentioned, but by the way, you are unfortunate you had 2 solar flare during the, so you must have some radiation actually. But radiation protection is the one that is the kind of system-wise protection. So the people working on the space program try to make sure that more people will be able to fly safely into outside of Earth's environment. So that's what we are seeking for. So definitely, you're so young, so you will have the wonderful future for flying into space.
Thank you very much. Then we have a few questions from people who could not attend, so they are watching this over live stream. So Rebecca Phillips asks you both, will human ever leave the solar system? What do you think?
If we survive as a human race for another order of 1,000 years, we will, I'm sure, maybe even before that. So, of course, some people believe we have an artificial intelligence coming, and they will take over, and then it will maybe be not the human life, but the successor of the human life, which is some silicon life or something like that, and then they don't have a problem with lifespan. But I hope that we will continue as a human race for a few more millennia, and then we will leave. And it's always interesting to put things into perspective, because just as in a century, people think that's a huge, long time and millennia. But I mean, we have been around as a human race for a couple of 100,000 years, which is very short compared to the Earth's timeline, of course. But I mean, a few 100,000 years, 1,000 years is very little compared to that. And another interesting aspect, I can't stop here now, it's Mars. Can we make Mars a very pleasant planet to live on? Terraform it, as it's called, which would probably take some centuries, half a millennia at least. But again, that's a short time compared to how long we as humans have been around.
Yeah, agree. Need a long time for adaptation, anyhow.
Yeah.
Well, long means long, astronomically long.
Yes, then we have some more questions from Farah Salim. What is the hardest thing you experienced physically and mentally after you returned from space?
Well, situation is that you know that astronauts are very well trained. So whatever something happens under your control or expected problem, which is not the malfunction, because we learned the malfunction, but malfunction which we can expect is not called malfunction, I think. But if you don't expect something happen under the microgravity, and then it affect my case, the damages some experiment, then that was the hardest time. Fortunately enough, I didn't have any fire or decompression, which we needed to evacuate from the vehicle. But so the hardest part was some experiment, fluid dynamic experiment. Actually, small air bubble blocked the flow, which we couldn't expected when we developed the device on the ground, because air actually resides upper place, and then it came through the whole system. So that is the situation.
Let's see, what was about ground also?
Yeah, so...
Well, it's hard to say. I mean, when you just get back on the ground, you are a little bit physically kind of tired and not in shape really for the gravitation. So it's a little bit hard the first day. Some people get sick. Actually, I was happy I didn't get sick. But in the long run, well, I guess was been told I was going to be grounded after my second flight. I would love to fly more, but nothing which I think's been really bad. No, certainly not.
Okay, then we have another question from Adam Hjort. So, how will surgery work in space? I mean, the blood will behave.
Oh, that's for the medical doctor, that's for sure.
What did you say?
How will surgery work in space?
Surgery in space? Well, of course, it's difficult, but there is a surgery in space program that NASA developed. So actually, we used the parabolic flight, 20 seconds of microgravity environment, to test how we can suck the blood or that kind. The venous blood becomes kind of oozing, and also the artificial, the artery, because of the high pressure, we thought it actually spread out. But once there is some kind of the blood, the pooling, then even high pressure, it's not come out. So maybe we will be able to do some surgery, but the hardest part is securing the body securing and also the drapes securing, and then make the environment cleaner, the hard part, I guess. But that's we need it. Well, the moon, since it takes only 3 days, maybe, and also there are not a lot of the time difference for the command, so that we will be able to do the telescience or telemedication or telesurgery, but not on the Mars.
Okay, then we have another one from Miranda Jäderling. When did you first realize you were in space? Or were you so trained for this? You had everything planned out? Or were there like an moment?
Well, when I first realized I was in space, well, at the moment we had what we call the MECO, main engine cut off. And I mean, you go from 3G to 0G in a split second, and you notice it for sure. And yeah, was just laughing. We were it was me and two ladies actually sitting on what we call the mid-deck in the shuttle, and we were just laughing, and things started to float around. Yeah, amazing.
Yeah.
Wonderful.
That one I remember. Not exactly what I thought first time I saw Earth, but that moment I remember very well.
Yeah. Very nice. Do we have any other questions from our member here in the audience? One.
I was wondering how extensive and demanding, both physically and mentally, are the tests you have to clear to become an astronaut or to be selected.
How mentally?
Yeah, mentally. Well, I thought they were tougher than what you do than during the training, I thought. Maybe not so much mentally as physically. It was a lot of not very pleasant tests, some of them, I tell you. Spinning chairs and vacuum chambers without really telling you what could happen to you, and some other things. I was surprised that in the European selection then, I thought it was not very much psychological tests, except that maybe they observed you when you did the special space medical test. I think in Japan, at least nowadays, they have much more psychological tests.
Well, since I'm the first group of the Japanese astronaut, our medical check, including the psychological tests, are very intensive. But when the time we selected more and more groups in Japan, we actually reduced the medical the test small, shorter days and a smaller version as much as possible, because thanks to the medical space medicine data accumulated, we don't need some psychological test like the John Glenn's first time astronaut did. So that is the progress of the space medicine. And actually, since I'm a medical doctor, I was not afraid of any kind of medical test because I knew what they want to do, except the special the medical experiment which uses a special environment like a rotary chair or the centrifuge issue or maybe hyperbaric chamber, or etc. So. Generally speaking, we should not kill the subject during the test, so you can tolerate whatever the test is.
Very good.
Okay, thank you very much. A big round of applause for all the questions asked.
Thank you.
A big thank you to Dr. Mukai, Dr. Fuglesang. We will meet you again during the panel discussion later on in the afternoon. For now, I would like to invite you all to a coffee break. So coffee and tea will be served upstairs in the foyer. And I ask you to be back in your seats at 3:10 so we can continue with the program in time. So thank you very much and have a nice coffee break. So, welcome back, everyone. I hope you had a nice coffee break and that you have enjoyed the conference so far. So now it's an honor for me to introduce our third keynote speaker. He's a professor at the Japan Aerospace Exploration Agency, JAXA, where he is in charge of the BP Colombo project, which is Europe's first mission to send space exploration instrument to Mercury. It's difficult to pronounce. Mercury. He's in charge as well of the JUICE Japan project, which aims to send instruments to explore Jupiter and 3 of its largest moons. So please give a warm welcome to Professor Yoshifumi Saito. Welcome.
Okay. Thank you very much. Thank you very much for inviting me to this seminar today. And my name is Yoshifumi Saito from ISAS JAXA. ISAS is the Institute of Space and Astronautical Science, and that is a part of Japan Aerospace Exploration Agency. And ISAS is responsible for Japanese science missions. And I think that some of you has recently watched or heard about the Hayabusa 2 project. Hayabusa 2 is also our science mission. And Hayabusa 2 is now in, that is asteroid explorer, and now it's in its destination, Ryugu, that is the asteroid. And several days ago, Hayabusa 2 succeeded in separate the rovers that is developed by CNES and DLR. And maybe in the future, many new discoveries will be made. Okay, so today, I will talk about the collaboration between ISAS and IRF, and that is the collaboration between Japan and Sweden in space science, especially in the space science instrumentation. Okay, and my first slide shows the history of IRF-ISAS collaboration on satellite-borne instruments. I think the IRF is the Swedish Institute of Space Physics, and the first, actually speaking, this first line is not relating with the satellite-borne instruments, but this is an important milestone in the collaboration between ISAS and Sweden. Our ISAS satellite Akebono, that is previously called EXOS-D, data was received at S-range between 1989, that is just after the launch, to 2015 April, that is 5 days after the end of Akebono operation. So totally, more than 20,000 passes were received at S-range, and the duration is longer than 20 years. And talking about the satellite-borne instruments, IRF Kiruna provided IMI, this is Ion Mass Imager, on Japanese first Mars orbiter Nozomi in 1998. And 10 years after that, IRF Kiruna and ISAS developed Sara Sina on the Indian first lunar orbiter Chandrayaan-1. And another 10 years later, IRF Kiruna and ISAS developed MPP-ENA, and Tohoku University ISAS, IRF Uppsala, and KTH developed PWR Mephisto on Japanese Mercury Magnetospheric Orbiter Bepicolombo MMO. And 4 years from now, in the future, IRF Kiruna and ISAS are developing PEP-JNA, and IRF Uppsala and Tohoku University ISAS are developing RPWI on Jupiter Icy Moons Explorer JUICE. Okay, so almost every 10 years, we are collaborating with IRF on space instrumentations. Okay, and this is the IMI. This is the ion mass imager provided by IRF Kiruna for Japanese first Mars orbiter Nozomi. But actually speaking, before arriving at Mercury, Nozomi, due to the failure of the communication system, we have failed to insert the Nozomi into the Mars orbit. This picture shows the launch of Nozomi spacecraft in 1998 by M5 launch vehicle of ISAS JAXA. And this is the picture of ion mass imager on Nozomi spacecraft provided by IRF Kiruna. And this instrument can measure energy per charge of ions between 10 eV to 35 keV, and it can measure the ion species, including molecular ions, and three-dimensional observation can be made every 4 seconds. And this picture shows the this IMI instrument on Nozomi spacecraft here, indicated by this red circle. And although this it is the Mars insertion of this spacecraft were failed, but the instrument, most of the instruments function very well. And 10 years later, IRF Kiruna and ISAS developed this instrument together. Chandrayaan-1 is the Indian first lunar orbiter. And IRF Kiruna and ISAS developed SARA. SARA stands for the Sub-KV Atom Reflecting Analyzer, CNA, Chandrayaan-1 Energetic Neutrals Analyzer together. And this picture shows the outlook of the instrument, and the right-hand side figure shows the parts of the instrument that ISAS provided. And using this instrument measures the ENA's energetic neutral atoms coming from the lunar surface, and it made measurements on the lunar orbit. And different from the Earth, Moon has no intrinsic global magnetic field, but on the lunar surface, there are regions that magnetic field is strong. That regions are called magnetic anomalies. And this instrument succeeded in imaging the lunar magnetic anomalies by measuring ENAs for the first time. And another 10 years later, Bepicolombo MMO, this is the Mercury Magnetospheric Orbiter, will be launched. And this is the first spacecraft with complete package for monitoring Mercury's environment. And the launch is scheduled the end of next week, so 12 days from now. And this figure shows the Bepicolombo mission plan. And launch is scheduled on 20th October 2018 from Kourou in French Guiana by Ariane 5 launch vehicle. And the Bepicolombo mission consists of 2 spacecraft, MPO and MMO. MPO is Mercury Planetary Orbiter, and this is developed by ESA. And MMO is the Mercury Magnetospheric Orbiter, and this is developed by JAXA, ISAS JAXA. And at the time of the launch, these 2 spacecraft and electrical propulsion module is stacked together and launched simultaneously. And after experience 1 Earth swing-by and 2 Venus swing-bys and 6 Mercury swing-bys, it will arrive at Mercury in December 2025. So it takes 7 years to go to Mercury. And after arriving at Mercury, these 2 spacecraft are separated and extend the antennas and start observation. And MPO and MMO always orbit in the same orbital plane. And we continue the observation at least for 1 Earth year plus extension period. And this figure shows the MMO spacecraft developed by ISAS JAXA. And this photo shows the MMO spacecraft was in ISAS. And these figures shows the MMO spacecraft after deployment of the antennas. And MMO spacecraft has nickname MIO, and MIO stands for, in Japanese, the waterway or fairway that leads to this spacecraft safely to the destination Mercury. And the MMO spacecraft's target, science target, is to understand the Mercury's environment. And similar to the Earth, the Mercury is a big magnet, and Mercury has magnetosphere. But the big difference between the Earth's magnetosphere and Mercury magnetosphere exists. One is that Earth has atmosphere, but Mercury has no atmospheres. So Mercury has no ionosphere. And the intensity of the magnetic field of Mercury is much weaker than Earth. So the direct interaction between solar wind and surface is expected. So one of the important questions we have to answer is, how does solar wind control Mercury's environment? And this figure shows the current status of MEO. 2nd of May this year, the MEO spacecraft arrived at Kourou. And between May and June 2018, stand-alone activities for preparing for the launch is performed. And on 7th September, JAXA launch readiness review successfully completed. And we are waiting for the launch on 20th October 2018, the end of next week. And this picture shows the MMO spacecraft. You can see the MMO spacecraft covered by the protector here on top of the MPO spacecraft. And under this, the electric propulsion system will be attached. And this is the final photo showing the before delivering the this space or MMO spacecraft to the Bepicolombo. And on this spacecraft, we have 5 major instruments: MPPE, MGF, PWI, Musashi, and MDM. And MPPE and MGF and PWI are the complete package to measure plasma environment of Mercury. And 2 of these instruments, ENA and PWI, are the instruments developed under collaboration between Sweden and Japan. Okay. And this instrument, ENA, is developed under collaboration of Japan and Sweden. And ENA is one of the instruments included in the Mercury plasma particle experiment. This is the comprehensive instrument package to measure ions and electrons in the solar wind and in the Mercury's magnetosphere and neutral particles from Mercury's surface. And more than 100 members are participating to MPP experiment from Japan, Europe, USA, Taiwan, China, Russia. And this ENA instrument is developed under collaboration between ISAS and IRF Kiruna. And MPP PI is myself, and MPP co-PI is Sas Barabash in IRF Kiruna, and Japanese counterpart is Kazushi Asumura. And this instrument measures energetic neutral atoms, and energy of energetic neutral atoms provide information about the plasma precipitating into the Mercury surface. And this is the flight model of this instrument, comparing with the size of the coin. And the development of this instrument is made under collaboration between JAXA, ISAS JAXA, and IRF. And red part indicates the parts ISAS is responsible for, and yellow parts shows the part responsible, the IRF is responsible for. And overall mechanical structure was made by IRF. And this picture shows the preparation of this instrument. This is the collaboration work. And top left-hand side figure shows the parts that ISAS delivered to IRF. And the top right-hand side figure shows the assembling of this instrument at IRF Kiruna. And this picture shows the testing of this instrument, IRF Kiruna, and electromagnetic compatible testing was made at IRF Uppsala and at JAXA in Japan. And the final preparation just before delivery to the spacecraft was made in ISAS JAXA's clean room, and IRF personnel came to ISAS and did these preparations. And this picture shows the ENA on the spacecraft, MMO. And talking about another instrument on MMO, okay, the PWI. This is also developed under collaboration between Sweden and Japan. And plasma wave investigation, this is the PWI instrument. And this makes the first observation of electric field, plasma waves, and radio waves in Mercury, which no man has ever seen before. And the PI of this instrument is Kasaba-san in Tohoku University. And PWI consists of PME and Mephisto and WPT and CM. And Mephisto is the instrument that Sweden provided. And so this is the Euro-Japan joint venture. Okay, and Mephisto is the contribution from Sweden, and it is the largest or longest payload on the spacecraft. And this instrument is developed to explore the fundamentals of Mercury environment, electric field, and plasma density. And it will be the first investigation of strong electric fields and electric current systems induced by the interaction between the strong solar wind with the magnetosphere and the planet. And this instrument is composed of this very long antenna from tip to tip, 32 meters. And this spacecraft rotates one rotation every 4 seconds. So the tip of the antenna is very fastly rotating. So, and this instrument is led by Thomas Carlson in Alvin Laboratory KTH. He is the lead choir of this instrument. And also, this is Jan-Erik Walland. He is the co-PI of PWA teams. So he is in RF in Uppsala. So these persons are leading this instrument, development of this instrument. And we have to deploy this antenna at Mercury in the hottest environment because Mercury is very near to the sun. And it is one of the most risky action of the BepiColombo MMO operations, and this is a big challenge. Okay. And so now we are waiting for the launch of this spacecraft end of next week. And usually I'm going to go to the launch place. And usually always I look at the launch. I pray for the safe launch, and because we can do nothing for the launch. So we are now praying for that. Okay, so 4 years later, in the future, in 2022, Jupiter Icy Moons Explorer JUICE will be launched, and it will arrive at Jupiter in 2030, and it will be inserted into Ganymede orbit in 2032. The destination of this JUICE spacecraft is Jupiter and Galilean moons. And about 400 years ago, Galileo Galilei pointed his telescope to Jupiter and discovered 4 celestial bodies circling Jupiter. And the discovery of these 4 celestial bodies that are Io, Europa, Ganymede, and Callisto, now it is called Galilean moons of Jupiter. And this discovery forced the human beings to change from Ptolemaic theory, that is the Earth geocentric theory, to Copernican theory, where the Earth is no more in the center of the universe. So this should have been the big turning point for human beings, because they had to change their way of thinking nearly about 180 degrees. So the destination of this JUICE spacecraft is 3 of the Galilean moons, Europa, Ganymede, and Callisto. And these satellites are called icy moons. And the JUICE is in the final stage to be a Ganymede orbiter. And JUICE is a large-scale mission for the study of Jupiter's icy moons led by ESA. And one of the largest internal outer solar system exploration missions in history. And the purpose of this, the objectives of this mission is to explore the possibilities of the life in space and the origin of Jupiter. And what is the icy moons? Icy moons is the satellite covered by icy crust. And these icy moons rotate around Jupiter. And while rotating around the Jupiter, this is deformed by the tidal force. That is just similar to the rise and fall of the tide that can be seen in Earth's oceans. And so by the motion of the tidal deformation, it heats up inside of the satellite, due to the friction force. So this means that there is some heating source inside the satellite. And that heat melts some part of the ice. And it is believed that below the icy crust, there exists a subsurface ocean that is liquid water. And the existence of this liquid water and heat source means the possibility of existence of life in this subsurface ocean. So the questions JUICE has to answer is, how are planets formed, and where can we find extraterrestrial liquid oceans, and what is the environmental change occurring in our solar system? And this figure shows the JUICE mission timeline. JUICE will be launched by Ariane 5 in 2022. And JUICE will be inserted into Jupiter's orbit in January 2030. And it will be inserted into Ganymede orbit in 2032. And mission will end in June 2033. So this is a very long mission, and continue from now about 25 or 20 or 25 years, 20 years. And JUICE will be the world's first icy moon orbiter. And on this JUICE spacecraft, 11 experiments are on board, and 2 of these experiments, PEP and RPWI, are led by IRF Kiruna and IRF Uppsala. And these are the particle environment package and radio and plasma wave investigation. And we are participating in this development of these instruments. And this figure shows the PEP-JNA. And PEP-JNA is a particle environment package, jovial energetic neutral atom analyzer. And this is the PI is Tasparavash in IRF Kiruna, and a counterpart of JAXA is Samura. And this instrument measures backscattering and sputtering particles generated by precipitation of high-energy plasma particles on Jovian icy moons. And the science objectives is to understand the Ganymede's magnetospheric structure and role of icy moons on material transport in Jovian magnetosphere. And this figure shows the cross-section of this instrument, and yellow part is the part response the ISAS is responsible for. And another instrument, RPWI, is radio and plasma wave investigation, and the PI is Jan-Erik Walland in IRF Uppsala, and co-PI is Kasaba in Tohoku University. And this instrument measures the radio and plasma waves in Jupiter and around Ganymede. And this red circle indicates the Japanese contribution part, that is high-frequency receiver and preamplifier and part of the software. Okay. So this will be launched in 4 years in the future. Okay, so starting from the ion mass spectrometer provided by IRF Kiruna for a Nozomi spacecraft in 1998, almost every 10 years we are collaborating with on space instrumentation. And 20 years after our first collaboration, this year, and the end of next week, Bepi Colombo will leave our planet Earth for its destination Mercury with instruments developed under collaboration between Sweden and Japan. And 4 years later, the Jupiter Icy Moons Explorer JUICE will leave Earth for Jupiter system and Ganymede, also with the instrument developed under similar collaboration between Sweden and Japan. And I think that the collaboration between Sweden and Japan on space instrumentation will continue forever. And our destination is expanding, starting from Moon and Mars and Mercury and Jupiter, and to far beyond in deep space in the future. Thank you very much.
Thank you for a fascinating presentation, Professor Saito. Do we have any questions for Professor Saito? Yes, we have one over there.
Is there any way of confirming the theory that there might be liquid water underneath the surface?
Yes, you mean theory or the previous observations?
The theory.
Theories. Yeah, well, if the liquid ocean exists, well, it is rather easier to deform. If the no liquid ocean, it is very stiff. So the deformation of the satellite is different, with or without existence of the liquid water. So that can be predicted by Siri, and they estimated the deformation size. And if the liquid water exists, deformation will be an order of meters. And without, it is less than that. So we can distinguish using the laser altimeter, for example, by measuring the distance between the spacecraft and the surface of the satellite.
Thank you. Any additional questions for Professor Saito? We will meet you again during the panel discussion later in the afternoon. So thank you very much for this fascinating presentation, and a big applause for Professor Yoshimi Saito. So, as we have heard, and what was mentioned earlier was that Sweden and Japan has a long history of cooperation on various space projects. And to tell us more from the Swedish side of this collaboration, I would like to invite the Director General of the Swedish National Space Agency, Anna Ratzman. Welcome.
So, thank you so much for inviting me here, and I really love the theme of this conference. I mean, sparkling interest of science through space, because I think this is so important, and is really important for both me and the agency. And also, I'm really happy to be here to celebrate the long cooperation between Sweden and Japan. That's been, as we know, 150 years. But within the space arena, we almost have collaboration for more than a little bit less than 50 years, and I think that is really impressive. And I also agree with the former speaker here that space is a fantastic tool. And that's one of the reasons why I have been working with this, in this space area for more than 25 years, because it's so exciting, the infrastructure and everything we can do in space. So the Swedish National Space Agency is actually the space agency in Sweden, and we are under the Minister of Education and Science. We are a very small agency if you compare to JAXA, but I can promise you that we do a lot of different things even though we are very small. The budget is less than 100 mega euro, especially now when the exchange rate within the euro and the Swedish krona is really awful, to be honest. And we have been established in 1972. And what do we do then? With our money, where 2/3 of the money go to ESA. And the rest, 1/3, go to Sweden and other international collaborations. And what does that mean, actually? That means that approximately 250 million Swedish crowns go to science. 150 million Swedish crowns go to Earth observation, the airfield. 500 million Swedish crowns go to technology development, and the rest is like working for sparking the interest of space in science and things like that. So it's a lot of money, of course, but if you ask me and the other people in the agency and all the other space stakeholders in Sweden, I think they believe it's too little, because there's a lot of things people like to do within the space arena. And what's our main task? It's to really distribute these grants for research and technology development, to initiate research and technology development, to act as a contact for cooperation, and also sparking interest of science through space. And we also have a lot of collaboration. Of course, ESA is very important, but also here we have a lot of other countries that we collaborate with. And it's really important for us, of course, because we are such a small country. We do a lot. We have some really key competencies that is world really, really, really good. But still, we have to cooperate. So when we say we build a Swedish satellite, it's always in collaborations, bilateral, trilateral, or through ESA or things like that. And the same thing is, of course, for the science part. I think actually that we are quite unique to be such a small space country, because we have had built up during all the years competence within designing and building satellites, including the science part. And this one, the Freya, that's my baby. I worked with that for 5 years, and what was so fun when I was newly graduated from school was that I jumped into a very small design team, and we were able to do all the different phases. We designed the satellite, we made all the calculations, we went up and bought all the equipment and had the interfaces to the scientist, then we put it together, we tested it, launched it, and then got the data down again. And that was such a great school. So if I can give some advice to you young people here, to be involved in some part at least in this kind of project is really fun and really a good learning school about space. So we had this very good different kind of satellites. I think actually we have launched more than that. We were also the prime of the first in Sweden for the first mission to the moon called Smart 1. And actually here was a break, because we couldn't afford this. It was quite big, these satellites, quite large and cost quite a lot of money, and we couldn't actually handle that because we had so much things we had to do. So we now started a new series of satellites called InnoSats, and that's the first one is here. It's called Mats, and next one is Sieve. So this one is around 40 kilos and is going to be launched next year, because you can do very highly sophisticated science even though you have smaller satellites. We have to go that way. But it's extremely important for us to do this and continue this competence. And here is the next one, Sieve. We have started a study about that one. This one is a really old one called Odin. It was launched more than 50 years ago. It was expected to last for 2 years. It was making science about the universe, how the born of stars is, so things like that, but also looking into the atmosphere. And now they have given the data, scientists data for more than 15 years. So that's really impressive. And also, as we just have heard by the previous speaker, that we are involved in a lot of different science projects and different levels and different ways. And I will not go into all these missions, but I can just tell you that we have around each year around up to 200 scientists actually working with space due to what we try to support from the National Swedish Space Agency. And that's extremely also important. I say everything is important, but it is. It's very difficult to say this is more important than other things, because you have to have the full picture and support everything. And also, this is important. As Christer told you before, he has been helping us in the agency, traveling around the whole country. I think you have met more than 25,000 pupils, haven't you, during the years? Yes. And this is really great. And a lot of pupils, and I heard from them, oh, well, we have listened to Christer. So that's extremely important for the young people today to get this possibility. And we have also, what we are going to do in the agency now in the near future is that the government of Sweden published a space strategy. We have been waiting for that for a long time. And that's a document that has been delivered to the parliament. And now it's time for us in the agency to make our strategy. And right now we are in the middle of a very open process that all the stakeholders in Sweden are able to give their views, ideas, where we should go in the future. And what we will do actually is, because we will have a long-term goal, but the budget is the strategy itself has to be within our budget. But then we will have a delta there, and we will tell everyone if we can have more money, we could do this additional work or have this additional tasks. So that's how we're going to plan to do it. So when we talk about collaboration between, a very important collaboration between Sweden and Japan, this is a project called Descend. It's made up with S-Range, our rocket range in north of Sweden. And this was a test of the next generation aircrafts in Japan, as JAXA is a tester. And they were dropping, you can see here, maybe you can see here, you can see this model of the aircraft, and is lifted off with this huge balloon. It's lifted up to, I think it was 3,000 kilometers up. No, it's 3,000 meters. hope so. Oh, no, I'm tired. Sorry. Very high up, and they were dropped, and they were measuring the sonic booms to see if it is a perfect shape of it. And they made 2 of these tests, these drops, and was really successful. One other thing is that we have been collaboration with data, taking down data from a lot of Japanese missions due to our location north of Sweden. So this have we done, as you also said earlier, for many, many years. And I know that there have been a very good collaboration between the 2 countries. This is also, you know, SSC, Swedish Space Corporation, has one of the biggest networks of ground stations around the world. So they have used, and one hub is at Esrange. And here you can see some of the antennas, but we have much more than you can see here. And over here, I can point out, over here we are planning later on, hopefully, to build a new launch site for our launching satellites up to space. Hopefully. And we also been involved in what is happening right now, the mascot lander. The mascot is European, and on this mascot we have an onboard computer from a Swedish company called Cobham Geisler. And it was last week I went to IIC, the big conference, as you did, and there was a lot of news about this measure, if it was alive, if it was working, everything. It was so exciting. Also, the same company has also got their processors on this H3 launch vehicle, and that's a long-term commitment. So we're going to have Swedish processors on this as the launch vehicles. And also this one, Bepi Colombo. And this started a long time ago, this mission, this project. And all this is also both, as you know, signed instruments from Sweden, but also there are processors and things that computers from Swedish companies, Cobham and also ROAG. And also I know that in Japan also was interested in green propulsion, because we have worked with that quite a lot in Sweden. And I know also that you have bought some this propulsion to Japan to test how good it is and how we could use it. I don't know actually the status of that now. But I must say, I think it was a little bit more than 1 month ago, I went to Kourou to see another launch from that launch site. And I was lucky enough to look at Bepi Colombo. So I saw these in the clean room and we're ready for launch. And so I'm also really excited to see, and I really wish everyone good luck with this mission. So we will see at the end of next week. So what do we do also for really engaging young people to work with space? One thing that has been really good is what we call Spexus Rexus. This is collaboration between Sweden and Germany. And here we are each year, we launch from Esrange 2 rockets and 2 balloons. And on each balloon or each rocket, there are several experiments. So young people can go together and apply for going on with an experiment, suggesting with experiments for this. And also you can be from Germany and you can be from Sweden, but you can also get in people from other countries also in your team, like from Japan if possible. And the project time for the balloons is approximately 1 year, and for the submarine rockets is 1.5 years. More than 1,000 young people has been sending up their experiments from Esrange. And now at the IIC, this big conference, you can see a lot of people that have been involved in this project. Now they are scientists, now they work in the space industry, and they seem to, I haven't done that, but I can see it as a club. You know, oh yes, I was in 2000, yes, I was at. So these really are good collaboration people, and I think it's a good, really good project. We also have a lot of couple of scholarships that the agency gives to young people, to Alpbach and also to NASA. Also ESA, if you go into the webpage of ESA, you can see there are also a lot of possibilities there. And what we also do quite a lot is really to engage teachers, to learn them how to really engage people about space. And they are a very big interest in that area. So by that, I would like to finish my speech, and I would like to add one final comment. And one of the reasons I've been working with space for so long time is that it's so fun. you can do, it's really hard, you work hard, it's sometimes you're really tired, but you have a lot of good friends, it's always challenging, you can always learn a lot of new things, and as I said, you have fun. So I think it's good advice to all young people, you should work within space. Thank you.
Thank you very much, Hanna. Thank you. We will continue now to hear a presentation from the Public and Science VA, an organization founded in 2002 to promote the dialogue between science and society in Sweden. So, and one key activity since the foundation has been to conduct annual polls about Swedish attitudes towards science and researchers. To tell us more about this work, I would like to welcome the Secretary General for Public and Science VA, Cissi Askvall. Welcome. Yeah. We work at the same. Yeah. We work at the same place.
You can hear me?
Yes.
Yes, you can. Very good. So, VA, Vetenskap och allmänhet, or in English, Public and Science, is a non-profit, a civil society organization. And as all missions for space travelers, we also have a mission, which is to promote dialogue and openness between the public and researchers. And of course, that can be done in very many different ways. So, for instance, we have run contests where we invited young people and kids to draw themselves as scientists. So once you become old enough that you start working and imagine yourself you being a scientist, what would you do? What kind of research would you do? And there will be a few pictures still of those more stereotypic kind of researchers, but most of them are really about young people being involved in science, and especially natural sciences. A lot about dinosaurs, but also very much about space. And this is a really nice example, I think. This is Hugo. He's a boy, he's 6 years old, sorry about that. He says, I'm researching how a new space rocket would work. It will be like a train, able to travel super fast out in space. It will be similar to a holiday trip, but up into space. And you can live in the rocket, and I will fly it myself. So that contest, Draw Yourself as a Scientist, was part of an annual science festival that Vetenskap och allmänhet, Public and Science, is coordinating throughout Sweden. There will be activities in about 30 cities all around Sweden, organized by local universities, science center, etc. And there's always a lot about space. This is actually part of a even bigger science festival called the European Researchers' Night, which has taken place annually ever since 2005. So it's about 30 cities in Sweden and more than 370 cities around Europe. And this is really where researchers and the public, especially young kids, meet. And the motto of this festival is researchers are ordinary people with extraordinary jobs, which of course can be said about astronauts as well, right? And one objective of this science festival is to make people more interested in higher education and research. And generally, Swedes are really interested, and they also have high confidence in researchers. We have measured this confidence annually since we started in 2002. And as you can see, it's few Swedes that have low confidence. It's rather, if you see the gray curve, that they have no opinion because maybe they don't know so much about what does researchers do, so they don't have an opinion. But very few have actually a low opinion. And also, there's a high confidence in the institutions where researchers work, in universities and higher education institutions. So it's about the same level of confidence as in researchers. But when we ask about confidence in different research fields, and now it's getting really interesting, I think. So which confidence do you have in research conducted in Sweden within these areas? These are the ones talking about very high or fairly high confidence. The curves are showing that there are quite large differences between medical research, technology and natural sciences, the free curves, high above, you see among about 60–70%. And then the lower, the green and the black curve is about social sciences, humanities, and educational sciences. And you see that's significantly lower. And why is that? What do you think? And this, I must apologize in advance for this graph, because we also ask the public which fields of research that they think that Sweden should be investing in at world-class level. I'm sorry. As you see, Dr. Mukai, heart and lung diseases, what you used to work with, highly regarded. But when it comes to, so yeah, I'm not sure you can read from behind, but it says environment, IT, pedagogy, and then the light blue down below, that's space, I'm afraid. So that's strange, because we know that people are really interested in space, engaged in space exploration and so on. So it's kind of a paradox. But I think maybe it's also a matter of wording. Because if you just ask about space research, that's one thing. That's something up in the blue or in the black. But if you also talk about how such research really can be beneficial to us all living here on the Earth, I think you will get a different answer. This picture is actually from a survey we did with young people a couple of years ago, when we asked about how they perceive different words. And you see the up in the right-hand corner, it's knowledge. That's a really good word. It's appreciated. It's something that you need to have, and it's good for you, and so on. Conduct research is also quite positive, but if you talk about researchers or performing science, that tend to be more of for specialists or for you know, some people in my school class, but it's not really something that everyone could do or are interested in, or could even be boring. So I think that how you state, what words you use, that really matters, but also how you engage with people. When we evaluate this Forskarfredag, this science festival events or other activities that we organize, we see that young people, and everyone really, appreciate when you are invited to be involved, allowed to ask questions like today, to participate actively. And also when the issues discussed are topical and connects to everyday life. If it's transdisciplinary, like this is a picture from a science cafe, and it's really about a researcher telling very briefly about his or her research, and then there's a microphone going around. This is even a microphone which you throw around, the orange thing there, and everyone is invited to take part in the discussion. You can read more about science cafes on that website, sciencecafe.se. And also, if you are invited to do things yourself, to take part in experiments, to do things hands-on, to be part of something that is really fascinating or spectacular, like a volcano erupting, and of course, if there are role models. And I think if you combine all those things, hopefully we will be able to do that, next year, when we will run jointly with a lot of other organizations. Among many of you here will be involved in this mass experiment. You can really engage young people and the public at large. This is about, sorry, this is in Swedish, this is about light pollution and how to measure light pollution using a very simple method. It's really a little tube made of ordinary paper to watch and count stars in different locations throughout Sweden, and being part of a research project. We are really looking forward to that one. And that will end my presentation. Thank you very much.
Thank you, Sissi. Some food for thought going into the panel discussion later on. So now from attitudes towards space science to space technology transfer. The company Umbilical Design's focus is to commercialize space technologies for a sustainable Earth. And it's one of 16 European companies which has been selected by ESA as a space broker to oversee the transfer of technology from the space sector down to Earth and Swedish industry. So to tell us more about this is the CEO and founder of Umbilical Design, Cecilia Hatch. Welcome.
So do we have sound? Yes, everything is here. And you are here. I'm so happy to see you all here. It's a really fantastic that we have so many interested in space, and we want it to be more and more people over the period that comes, because we need more people in the space sector for sure. So I'm happy to introduce to you all about space technology transfer. And if you haven't really got the point yet, why space? It's of course because Earth depends on it. So I will be also happy to share some projects we have been working with over the time, and the role as ESA space broker. But all actually started with a diploma work. I was studying industrial design at Lund Institute of Technology, and luckily Lund had a cooperation with NASA in Houston Johnson Space Center. So it started with this little vehicle called a crew return vehicle, but also called a space ambulance that was planned to be attached, as you can see in this picture, to the International Space Station. So we were actually 4 students, 2 design students and 2 architect students working with the interior layout of this little vehicle. And luckily enough, we had by then our astronaut Fuglesang there training, so we got fantastic help from him and a team of astronauts supporting us in this very exciting project. And talking about exciting, it was mentioned earlier, today we were lucky also to go up in this weightlessness flight to test prototype a section of the vehicle. We brought it up in this plane to test the prototype and see what's good for seat structures and everything. And on every parabola, this plane goes up and down like this. So you have 30 seconds of weightlessness where you try out your solutions. And it's repeated not only once, but 30 times. So it's 2.5 hour great and fun flight. So I can recommend it for everyone. And this was the result after this amazing, fantastic work. You can see to the right the 3D model, and this was way back in year 2000 we did this project. And the major change we did with the vehicle interior was that instead of having like a flat floor with 7 seats placed up on the floor structure, we instead integrated the seats in the floor structure to save weight. And that's always popular in the space sector, as it costs around or more than $10,000 per kilo what you decide to bring up in space. So saving weight, very positive. And we also calculated exactly how much more volume we could give to the technical systems that were planned to be under the floor structure. So here you can see also to the left that we also did like a full-scale mock-up to really show that this should be a possible solution. So I was so inspired that I thought, oh, I must continue working within this exciting field. So I decided to start my own company, Umbilical Design, directly after my master degree of industrial design from Lund. So working initially only with space architecture within that field, after a couple of years, we realized that we really want to see how can we now transfer technology from space to Earth. And since a long time now, we work as one of 16 ESA space brokers in Europe, and we have a strong focus on sustainable development. I will come back to that. So the main focus is to take all the lessons learned, materials, technology, concepts from space industry and see how can that now create value back on our planet. And if we have challenges here in Sweden that we can't solve on our own, we have this amazing network of space brokers now in totally in 16 countries in Europe. So we have fantastic support and teamwork. I will mention a few projects we have been involved with. Of course, I would like to take the opportunity to mention a fantastic Japan project. I was invited as one of 9 space architects, and it was to present a future living concept where I developed something I call a sea scraper. So instead of a skyscraper, I wanted to develop a sea scraper to be standing in the sea, to use the water to cool and heat the building. And I also took inspiration from the work with the crew return vehicle or little space ambulance. You might see that the idea was to have small plug-in and plug-out modules that you could move them between different sea scrapers that I envisioned could be in different places around the world. And this was also a way of lift the question of the rising sea levels. So another project we have been involved in that was very much to be a create public awareness what you could do with space technologies and materials. It was called Couture in Orbit, from Spacewalk to Catwalk, and it was a project in cooperation with both ESA and the Science Museum in London. And this was to mark the missions of 5 ESA astronauts between 2014 and 2016. So we worked also with the fashion schools in these different countries and supported them with materials and technologies that could be interesting to use in fashion industry. We moved between many different industries. So here you can see how I'm trying to be ambulance driver for a day. Actually, it was a project where Karolinska University Hospital would like to investigate how we have worked with us way back with the space ambulance concept and the interiors, and see what can we transfer into the ambulance. We were also into Karolinska University Hospital in the surgery rooms and see what could we help with for different technologies and materials. So very important and exciting project. Another working day for us, me and my team. So here we are now a bit differently dressed and working with the steel industry. Here the project was to do ideas and concepts for the future control room. But here we realized that actually, I mean, these clothes are quite okay, but we realized that the underwear were not really good protection for the workers. So we decided to actually, to our own surprise, also go into the underwear business. And we developed the underwear together with Björn Borg. It's in a space fabric used normally in the astronaut suit. And this textile can resist heat up to 350 degrees Celsius. And it now protects steel workers from burns and scars. And it's no coating. It's a fiber of the material in itself that resists the heat. And it's biodegradable. Of course, you have to give away the first couple of underwear to the right person. So I was happy to meet up with Richard Branson when he was here in Stockholm. But from underwear to urbanization, which of course is the major part and where the heart really lies, we see we can support and help with a lot in this field. From lessons learned of the living in space, as mentioned, of course, both our 2 astronauts here today. We see a lot of insights and technologies that would be really amazing if we can bring back down to Earth. So here we have been working, for example, with a project we call AstroCity, with funding from the Swedish Environmental Protection Agency, just to look into everything from water recycling. As Krista mentioned, it's 90% that can be recycled, and it has also been transferred into a building at NASA Ames Center, where we have been several times looking into this, and meaning that the building on Earth consumes 90% less water than a traditional building. We also look in different technologies that also can help out with new colors that is more isolating, or air filtering to create better environment inside buildings. And I also, of course, I think everyone has brought up almost the Moon Village. Through Moon Village, we expect to learn a lot about everything from like 3D printing, robotics, and artificial intelligence. And I also, at the Strasbourg Moon Village workshop where I attended, I also had the pleasure of listening to Mr. Yamamoto, Vice President of International Relations from JAXA. And what I found so exciting and so inspiring to be there, it was all space agencies was really present at this workshop, and it's all about, as you have mentioned, it's all about this cooperation that we work together, and it's also, as Anna mentioned, it's also the passion and the great fun of work together that is so important. And it's also that we need to work together with this kind of complex projects. We can't do it on our own anymore. So it's about global cooperation. So maybe a few of you, or maybe hopefully many of you, have heard that, I mean, it was only a couple of years ago that the International Space Station actually got nominated to the Nobel Peace Prize. So I think we have a lot of learn, and I think it's not only the technologies that we should bring down to Earth, but it's also the vision for a global cooperation. And by that, I want to say thank you very much for listening.
Thank you very much, Cecilia. So going into our next session of the program, I would like to invite our invited speakers again to a panel discussion. So please welcome Dr. Chiaki Mukai, Dr. Christer Fuglesang, Professor Saito, Anna Ratzman, and Måns Holmberg up to the stage again, with a small round of applause, of course. So the theme for the panel discussion, we will explore the theme of the conference, to how to spark interest in science through space. So how do we raise interest and awareness in science through space? And we heard some examples already on efforts on how to do this, but I would like to start with by asking our invited guest from Japan, what kind of efforts are you involved in personally, or what efforts are JAXA doing for increasing the interest in and the awareness in science and space? So,
okay, the first personal experience, and in case of the launch of Bepi Colombo next week, I'll go to the launch place and visit the schools, local schools, and I'm going to explain what is a Bepi Colombo mission is, and what is the purpose of my instrument is, and how it is interesting, and how we are expecting the results of Bepi Colombo. So I will explain like that. So that will be some kind of will spread the knowledge of space and interest to the public. And in case of the our institute, well, a new exhibition of the ISAS to the public is opened the new building was opened last year. And another thing is that the results of the research is press released maybe more than every month. And now it is our Asteroid Explorer Hayabusa is in its destination Ryugu. Its result is press released almost in real time. So,
and Dr. Mukai?
I think maybe the two kind, like the one is the science, like Bepi Colombo, or you mentioned, the make people feel like, wow, that's wonderful. There is an icy moon in the Jupiter or something like that. And then we have an educational program, and then that kind of science, basic science, the wow, impressive type of impression, the things is the one that we encourage students to work. That is the one way. And the other one is that, like I do, connect any kind of space program to your daily life. Then maybe space medicine for the preventive medicine is easier to connect. Use the SDGs as a reference to connect many space activities. As a matter of fact, ESA has developed some catalog that each space program connected to the SDGs, which is very much affected to our daily life on the Earth, on the Earth. And then we have an educational program to do that, two different way of connecting the space to the people. And of course, astronauts like Krista does. We go to the educational program, starting from the small children to the senior people, like that.
So, how is the situation in Japan? Do we face the same sort of problem? Are young people inclined to pursue scientific careers, or how is the situation there?
Well, situation is if we if the student needs to go to the space faculty, sometimes the space business is still small, so that the after finishing the space the faculty, sometimes it's hard for the student to get into the actual the business situation. So that's also one of the reasons why our university established the habitation, like that you explained. If we have the research related to the habitation, living part include housing, air and water filter, or food, or any kind daily life. But if we target the research on the moon base or whatever the outside of the Earth, we have to clear the higher level of standard compared to the Earth, which means the students have some specialties, and then the output will be space, so that they can get a lot of the opportunity for art business or working place, but still dream on the space and motivate people. So I think the housing or living condition to introduce to the space entity, not only the rocket system, not only the satellite system, but the housing habitation would be the good way to more young people to get in the program.
Yes, yes. So, Krista, you talked about some of the activities you participate in. Would you mind sharing a little more details on the various activities you do to raise interest and awareness in space and science?
Well, it's very easy to use space to create enthusiasm and inspiration, because I think everyone has a kind of a relation to space. I mean, you just have to go outside any cloudless night, and you have all these stars up there, and it's fascinating to look at them. And at the same time, there's what could it be? Where are they? What is it? And you can fantasize about it. And then the other thing which people really are interested in is other people. So if you combine this, space and people, it's unbeatable, basically. And so that which happens to be the astronauts. So just go there and talk about your experience. Normally it creates a lot of interest. But of course, there's so much more. I mean, space is the ultimate frontier. And it's easy to kind of, for young people, say, wow, that's something I want to do, I want to be part of. And that's, the goal is to create the feeling that this is so interesting, so fun. I want to know more, I want to be part of this. How do I do that? Well, I need to learn more about probably STEM, science, technology, engineering, and mathematics, right? So out and talk to schools and write things. As I mentioned, I actually written a few books, which is kind of a story for kids, but it's also some popular science in there for kids. And we have an organization that's not called the ASE, Astronauts, the Association of Space Explorers. We have a yearly conference, which goes around different countries. We had in Sweden 3 years ago. And then around 100 astronauts, and the most important part of that is actually how all these astronauts then go out to schools or universities in that country to get a very strong kind of impact. So that's some of the things. Then university level, like a student satellite to kind of get me interested in space as well. And as Anna mentioned, you're part of working with a satellite, real space hardware for something. That's something you really learn a lot from, and then you can maybe want to continue with that. And hopefully you can also create enough that some people want to start their own spin-off companies. In Denmark and in the Netherlands, some very successful examples of that, where students built these small CubeSats and then they started companies, GomSpace and ISIS, which is also something really great if we can. Well, I'll stop there.
And Måns, the Swedish Astronomical Youth Association, you mentioned you have 3,700 members.
Yes, we do.
So what are some of the efforts that are made from your organization?
Yeah, so can you hear me? Yes, good.
Maybe you talk here.
Okay. Okay, so as Christer here was saying, that astronomy in space is such a forgiving topic because everyone is interested in it. Like all children, when they are young, going to school and teachers teach them about the solar system. Everyone is like, wow, and they go out, see the Milky Way, and are just so fascinating. But then the interest starts to drop off. Like space is not cool when you grow up. And we want to stop that because I think it's not true. Because we are all here. And so we regularly organize astronomy camps, summer schools, and star parties where we go out and watch the stars with the telescopes, and other events all around Sweden for all young ages from 6 to 25 years old. And then we also have 40 local organizations to spread space and astronomy and make it accessible locally to everyone in Sweden.
Oh, great. So, Anna, you mentioned some of the efforts you are doing from the National Space Agency side. Why is it important that you engage in these, in this area?
I think it's a lot of reasons, actually, because I think it's, I can just mention before I say that, I can say another initiative I've been speaking to not quite recently is something called Berättarministeriet in Swedish. It's that where you have non-profit organizations trying to help young kids to be interested of read and write, and also use the fascination, I cannot talk today, to really about space and everything. So they have created, they have a redactor that they have, is but not a real one, saying that he would like to have help of all these young people. He called them the galactic experts of universe. So I went to this galactic expert meeting, and they were all going to should write a manual for people coming from another planets to Sweden. How should we treat them? And it was so exciting, and I was there as the national director general for the Swedish National Space Agency, and so I was there and talking to my team how they should write this manual. It was fantastic to see these young people how they engaged they were, and I think that is one good reason. And I also know that there's a gap there. It goes up and then goes down, and there really have to do something. But one other problem I think it is that people in general, they have not so good connection about the use they can have of space. They think science is one thing, but what you can do with the weather, or otherwise to understand the climate and to do other transparency to see where are the troops and everything like that, they don't connect that with space. So I think we all have to educate all the people that we are working with or meeting to try to explain this, what a fantastic tool space is. And I think that's a way really to get this more interested in space science or put more effort into that, because you can use it in so many things.
Mm-hmm. So, Måns, you mentioned that the interest sort of declines. When is the age when the interest start to decline? Where do we have to make the efforts?
That's a really hard question. Well, I don't really know. But I can say that, yeah, when children start becoming a bit older and other things become more interesting and people start doing football or doing other things, then really the interest in science and astronomy should be up there as well, but it's not. And yeah, it's about figuring out why. As I said, I think it's because children don't think it's cool and they don't know like how the career path can be. Like parents need to encourage children as well, because they don't know what you can do in space and astronomy. They think that the only thing you can do is to become an astronaut, and that's not true. So we have to work on that.
Dr. Mukai, Professor Saito, are there any efforts you would like to see to improve this situation?
The situation, this is recently I said that the Earth is also, the Earth where we live is a part of space. So sometimes, that's you mentioned that the people, if you people can connect the daily life with the benefit of the space, like weather satellite is one of them, global warming is the situation that maybe we need space asset to solve. So if we can just connect our lives to the space asset, and then I think people get interested in space. And then, of course, our life is very short. So space is not the only one that it's very interested in. The sports is good too. So, but space is an interdisciplinary area, so that you need a lot of expertise work together. So maybe the children who start the learning about sports maybe develop some countermeasures away from the viewpoint of space medicine and preventive medicine and etc. So if you can just see the output part to helping for both Earth as well as space, the explorers, then there are a lot of activities that you can connect your daily life to space. That's what I believe.
Professor Saito, would you like to add something?
Well, talking about the relation with space, I think in Sweden, the space is more closer to the daily life comparing in Japan, because you have aurora, and aurora is, well, I'm a researcher of aurora also, and aurora is the natural movie projecting the activity of near space. And especially in the northern part of Sweden, the aurora is, well, a part of the daily life. And the interest comes from the science, maybe. And on the other hand, in Japan, the aurora is just the target of sightseeing. So, well, talking about those, well, difference in the natural environment, I think, well, in Sweden, yes, the science is near to the space is near to the daily life, and, well, people can, well, understand those importance easily, I think.
So, Anna, are there any more efforts you would like to see? What would your dream scenario be?
My dream is really that when you can see that the people now that they are starting to get engaged, that they talk to a lot of other people, so we really spread this information around, and also get this. So it's okay to be interested in space, and I also have a belief that a lot of people believe that space is always so difficult, so you can't even try to understand. And also, I think some people also believe that's just something, what you do with space is just to have some fun and launch some fun rockets. And that's fun, of course, but it's not, it's so much more. So I think you have to widen their idea of what space is.
So how do you do that?
talk and communication, and maybe you can have competitions. You can a lot of different things. I think would be good, and we try as much as we can. Well, our very small organization, but we try also. I think we also should. I think this is important that all different stakeholders that work with space in Sweden and also, of course, in other countries could collaborate much more. So we can have some general good ideas what we would like to do within space, not saying the same thing, but if we can complement each other with different parts, that is very important for communication, we get a much stronger message. And I think that is more than understandable and more open their ears of people listening to this. So I think we also have to collaborate even more.
So I would like to invite you to ask any questions or comment on anything you might have. Oh, yes, we have a question over here.
I have a comment. My question will be whether you agree with the comment or not. And to the comment to the question you made, I don't remember your name. What age kids stop being curious about space? My comment is that they don't stop being curious about space. They stop being curious, period. And what I think science communicators should do is to raise the age where people stop being curious. And I think it will follow by itself that people will be more, will see it easier to enter in a science field, and from there into a space. As you said, space is a multidisciplinary field. So I think that the key point, and I ask you whether you agree, is curiosity is what we should make people be curious. That's, thank you.
So you agree? Someone would like to?
Yes.
Yes? So they all agree here. We have another question or comment over there.
Yes, you have not mentioned one important factor to keep the interest, and that is the job opportunity. Do you have to be a nerd, a scientist, or move to Kiruna to get a job if you're young and interested in space in Sweden? And I think this is one of the key success factors if you keep the interest. Thank you.
So job opportunities, would like to comment on that one?
I can try. I really agree. And what I think is really important to try to create ways that where you, as I said about this Rexus Spexus, these balloons and rocket, because when you do that kind of work, you get in connection with different space companies and also different space agencies. And I think that's one of the easier way to really get in, so they get to know you, so you can really start to work with them and things like that. But it's difficult. I agree. And I think it's also important. And we do what we can do, but we can do even much more.
I could add to that as well. I think it's very important to lift young role models that's doing space and astronomy, because then young people can relate. And it's not only the stereotypical boring scientist doing all the work. It's actually accessible to everyone.
Thank you. Anyone else would like to comment on that? Job opportunities? Oh, we have another question over there.
Well, I want to first, we scientists are not so boring at all. That's for the first.
Sorry.
That's for the first. And for the second, actually, I like very much discussion, because I wanted to ask you, even before the discussion started, that you by yourself stop to believe that curiosity is an important driving force for the human being. Actually, I will tell you, for research, so your pragmatic approach, we bring, application, we bring pragmatic. I think the curiosity is still extremely important driving force for it. And what's happened that people are not, that young people stop to be curious, because our ground school, it is not only Swedish, kills curiosity and explorative nature. So I think instead of putting a lot of efforts on the different organizations, trying to repair the damages, we should attack actually that objective which makes damages. Actually, ground school should actually keep curiosity and explorative nature. And one of the reasons is, unfortunately, that the role of the teachers were very depreciated. So I would encourage you to believe very much. Curiosity is extremely important component of the research, of the explorative. School kills that little bit, but let's work with the school not to kill it. And I was expecting you guys to protest when you saw this graph, you know, space on the very low level. I don't believe that. I have students in nuclear, and I can tell you we talk about space sometimes, and that's definitely not agreeing with this graph. So try to make it better. But I hope you agree that the ground school actually is the place when a lot of things are happening, and we are just, you know, just putting that little bit too much aside from this discussion.
Thank you.
Yes, a short comment, and I agree with you, but that's why we're working from the agency now a lot with teachers in Sweden, and we are educating the teachers to really keep the spirit ongoing and for space to get exactly what we're talking about here. But we can do more, but we have a good start there.
Yeah, for me, I agree with you. And first of all, we are not boring, the scientists. I would count myself as a scientist. And with the school, yes, we need to change a lot in the whole school system, that's for sure. Now, that curve which Sissi showed was annoying, I must say. Space at the very bottom. And I started to think, why? Well, I think one of the things is the huge misperception that, oh, anything with space is so expensive, so we don't want to invest in that. But the question was, what should we invest in for research, right? Say again?
World-class level research.
Yeah, should we invest in that? Well, space must be expensive, right? Well, if you do the math, with 100 million euros, which is the Swedish National Space Agency's yearly budget, divided by 10 million people in Sweden, that's 10 euros per person per year. 10 euros per year. Is that a lot? I mean, this is one of the messages we have to get out. And then, again, yeah, people, space research. There must be astronauts going to the moon. No, we can't afford that in Sweden. And the second thing is we have to educate people what is space research, which is everything from you take data with the Hubble Space Telescope and study the universe, and well, everything we talked about today, right? And how that benefits both our curiosity and talking about curiosity, and also help us at Earth. And then that space is so unclear for people. I mean, it's also this infrastructure which we use in space. It helps our daily life enormously. And that is, of course, not really space research, but if people realize that infrastructure is extremely important to help our life on Earth, there's some kind of research needed to improve that infrastructure, also make better satellite navigation and better Earth observation satellites and all that. But that's not very extremely expensive. So I guess we have a huge educational thing here, which is partly due to the success of the human spaceflight, because that is what people associate with. Or that must be expensive. Just think about how much they paid the Apollo program. Well, that was some reflections. So I don't know, but you have to work on it.
You have some reflections on working with teachers and schools in Japan?
It's not. Sorry, yeah. Before that, I just would like to comment on the curiosity. I totally agree with the curiosity part, and then how we can keep the children's curiosity high level. It is also very difficult, but interactive learning, let them think about let them think rather than teach knowledge, and then also let them experience that, wow, I discovered this. Wow, this is a new, the new idea that I have never come up with, or something like that. So something like make them feel like, wow, you did good job. Like a very small step is okay. But if they feel like, wow, I accomplished, then they keep going with the high level of curiosity. And also, I totally believe the science or scientist is not boring. But sometimes scientists have a very high level science, so that it's very difficult for ordinary people to understand why it is so interesting. So if scientists transmit the information well enough or enthusiastic enough that people feel like, wow, he's doing such an interesting thing which I have never ever understand, but I want to take a look at it. That's kind of the situation will be the one that the scientists will be able to do. Because it's a science, very high level, but sometimes hard for children to understand.
Yes, I completely agree that, well, I'm also the one of the non-boring scientists, I hope. And, well, yeah, it is true that for our scientists, the curiosity is the really big power to continue research. And I think we should, using the easy word to explain how we are really interested in science and new results and the data nobody has ever seen. So we have to explain using the easy word to the public how we are really interested in. So.
Yes, I completely agree. I just have to add, science is not boring, and sorry. It's just the stereotype that we want to change.
Thank you. So we have several questions now. Cecilia, would like to make a comment?
Yes, a short comment. As I've been out quite a lot in schools in a program I call Space Kids, I have understand a little bit about them more. And if they're under age of 10, they still have the curiosity. So that's why I focus on 8-year-old kids now. So that's an advice about the age problem we had before.
Thank you. And we had another comment over there.
It's not a comment, but it is tricky. Yeah. So I wonder, since this is like more about like collaboration. We heard like many story about collaboration between Sweden and Japan, but both countries have like problem about curiosity and like more people need to get interested in. But I wonder if there is any reason why Sweden and Japan choose each other, except for the fact maybe like you didn't have any choice. Maybe the only this Swedish university had this technology, but I don't know. But maybe this is more question to the Mr. Saito or Anna. But are there any competitive special reasons?
Well, one reason is that Sweden is in very good place. That you have aurora. And our research is very closely related with aurora and plasma measurement observations. So that is the starting point. And at present, well, there are 4 permanent researchers in Sweden, IRF Kiruna and IRF Uppsala. So that, well, the existence of the Japanese researchers in permanent with permanent position is in the Sweden makes our connection very close, very strong. So that is the reason why we are continuing to collaborate with Sweden.
And also my view is also that the Swedes think it's quite easy to collaborate with the Japanese people, because if you say something, you trust them and they trust you, and then you would like to continue to work together. So that also I think is one of the reasoning why we have been this different kind of collaboration during so many years.
Thank you. And we have another question over there.
Thank you for the opportunity. I would like to add 2 things, which are basically interconnected to each other. First of all, we talked about curiosity and being interested in space a lot, but being motivated to do something actually in the space field is pretty much important than just being interested in. And these people who are motivated enough to do something or to try to do something tend to move around in the world. And on the other side, like Dr. Carl Sagan says, we are all made of stardust. But when the countries who can provide the opportunities and competences to these people who are motivated tend to put this space science under the defense sector, it brings a huge barrier. And the people just stop there. So the next generation who see these people stopped after they are trying, they just lose all the interest in that one. That's what I wanted to add. Thank you.
Thank you. Any comment on that one? No?
I can just give a short comment, and you are right that ITAR regulations about what you can when you collaborate, that is a regulation that we have to fulfill to work with US and other countries, and we have really and that is a problem to fulfill this requirement that many companies think is very important. It's really not good for the openness in working collaboration with a lot of countries. That's sad, but that's the case right now, and I hope it will be a change.
So thank you. And the two last comments. Thank you. Yes.
The graph did not show the interest in space sciences and such things, because people are really curious about space and are interested all over. We all know that. But the graph shows the priority of what the money should be put in. And I think it's much easier to see that the use of cancer research, etc., is very clear. But they don't see what you just gave us today, the real good things out of space science, the good for Earth, for people, for medicine, etc. And that's what is the reason why they put the priorities so low. I think if you go on really telling about how this can be used, we'll achieve quite a different graph.
Thank you.
Yeah, I agree.
I agree. Yeah, I completely agree. And and also that space is really important, and many people take it for granted. Like, we use the GPS system all the time. We use satellite imaging, like image wildfires here in Sweden, like this summer, so that you could prioritize where to put your resources and stuff like that. Like, space saves lives. It's important.
Thank you.
Well, you could add one more aspect here if you want, a little bit maybe provocative. I mean, what's the biggest danger to kill us all? That's probably a big asteroid, which we haven't really seen yet, and we don't see it soon enough, like what happened with the dinosaurs 67 million years ago. That by itself should be a very strong reason for why we should invest more in looking out in the space and prepare and be kind of ready to counteract it in time if something happens. And that's, by the way, also something the Association of Space Explorers is trying to promote and increase that awareness about that problem. And this managed to create what's called asteroid day. Asteroid Day. Yeah, UN has declared some day in June every year asteroid day to kind of think about that. But you, of course, you want to be positive when you give messages, but you want to scare people. But I mean, if you do the calculations on it, it's a huge, very unlikely. But if it happens, it's extremely bad. So you know the balance.
So one last question.
Can you hear me? Yeah. Well, I'm the science teacher that is not boring also. So thank you for the previous comments, because me and my colleague, we work a lot about not just preserving the curiosity for our students, but also meaningfulness. Because they are born in a world where a lot of things are already set for them. So by looking back to our history and by looking forward to our future, we can also talk about what is meaningful for humankind and what science can bring for the future of humans. So we need to also address what is meaningful for our future generations, and that is a really important part of this discussion, because curiosity is one part, but you have to find that key essence in meaningfulness for the pupil, every one of them, because then they're attached and you can bring them along the what do you say journey. So
thank you. Any You agree on that one as well?
That one? Yeah. Is this the last one?
Yes, yes.
All right. You asked before about what we do for inspiration. I forgot to mention something that if you want to have more inspiration, you could come to KTH, Royal Institute of Technology, tomorrow. In the afternoon, where you actually meet the majority of the people who are here on the scene right now. Chiaki and Anna will be in a panel towards the end, and we will talk about the future human space flights and exploration, starting at 1 o'clock in the lecture hall E1. You can also find it on the internet, so you're all welcome there. And at first, we go to a place which Anna should know, Tolban, where she was a student once and had parties, and I will have a pub there after around 6 o'clock.
Okay, dagens tips, as we call it in Swedish. So thank you very much for this panel discussion. We would like to thank you with a round of applause and some small gifts from our organizations. Thank you very much. And for the last part of the program, I would like to invite the director of the Japan Society for the Promotion of Science, the Stockholm office, Dr. Tadahiro Tsumoto, for some remarks. Thank you.
So my name is Tadahiro Tsumoto, director of JSPS Stockholm office. And first of all, before forgetting to say, I would like to express many, many thanks to Dr. Chiaki Mukai and Dr. Krista Fuglesang and Dr. Yoshifumi Saito-san and Cecilia Hel-san and Anna Rasman-san and Sisi Askwal-san and other speakers. Also, I would like to express many, many thanks to all of you in this room for joining us today. You know, this symposium very fruitful and very informative, and also tell us many interesting stories. And as Dr. Anders and Dr. Turateri initially mentioned at the beginning of this seminar, this year, 2018, was a special year. That's the 105th anniversary year of beginning of diplomatic relationship between Japan and Sweden. So we have a very long history of collaborations between two countries in various areas, in many areas, including science and technology. And today, we heard that both countries have have common interest, or how to say, common scope, future scope into space science. So, and both countries share the same interest in space science, and also common scope to future science. And actually today's topics, space science, is a very attractive science. There's some discussion in the final panel discussion. And in my opinion, space science is one of the most attractive science. And in Japan, that's my experience. In Japan, I often ask to high school students, what is the most attractive science? And most of them say that's space science. Because space science is very attractive, and also in the final panel discussion, keyword appear. That's curiosity. That's a keyword. And lectures about space and also cosmos very interesting and attractive curiosity. What is the moon surface? What is the Mercury surface? What is, that's many very attractive story. And so I'm a bit optimistic view about how to make people pay attention to space science. Of course, there's some concern I'm talking about, but anyway, keyword was curiosity, and curiosity is just mentioned already here. Curiosity is of human nature, and also curiosity is the main driving force of scientists. Scientists are driven by curiosity. So curiosity is the driving force of science, and today we had many very curious stories from lecturers today. So I hope today's lectures excited and very interested to you, and also I hope everyone, I believe everyone here in this room really enjoyed today's lectures. So before forgetting, I'd like to say one more thing. So JSPS is Japan's main funding agency supported by Japanese government. So if you're interested in our JSPS funding program, we place leaflet or brochure in the exit of this room. So please take one if you are interested in this, our activities. Okay, finally, again, I would like to express many thanks to all the speakers here and also all the audience here for joining us today. Thank you very much.
Thank you, Dr. Tsumoto. And for the final concluding remarks, I would like to invite Stefan Gustafsson, Senior Vice President of Strategy and Sustainable Business at the Swedish Space Corporation. Welcome.
So, another 10 slides to finalize? No, of course not. It has been a wonderful afternoon. We are running over time. On the other hand, it's our reception afterwards, so some sparkling to spark some new visions and ideas. And maybe this also could do that. I'm a true believer that everything that we have heard here today will be part of our common future on a more sustainable humanity on the planet Earth. This, a global game change through space, will come through. It's not possible to predict the future, as you said initially today, but it's possible to work hard to achieve a good future. And if we do that together, collaboration, in good collaboration, we will truly create a much more sustainable planet. We have tried to figure out or define three trends where all the space science are used for humanity to benefit from space. These three trends, Earth's observation as the first one, provides opportunity to observe every square meter of the planet Earth every day, once or twice, already today. Why don't we have the information? Just because it is there, but no one is putting it together to recognize situation, picture possible to understand. Of course we should do that, for sure. For sure we should have a global watch center providing all this information for scientists and politicians or whatever it is to act on to save the planet. Another one is positioning. And combining Earth observation and positioning services is a great thing. I mean, the positioning systems of today is now a market, a commercial market worth over $100 billion US. Only at devices and taking care of the signals and do something about them. And you can imagine how much the market under that is worth, the downstream market, a lot. The third one is communication. Satellite communication that will provide opportunities for all humanity, not only 50% as for cable internet, but 100% of humanity to be connected to internet. I mean, we have seen here today that space projects are really, really long. We heard you telling about projects that will be launched 2033 and such things. On the other hand, space is now changing so fast, so the largest challenge for us all working in space is to keep up with the speed of change. Why? Because people are connected now. People all around the world are connected, universities, industries, institutions, and we work together, borderless, to a better future for mankind on our small and very, very sensitive planet. I've only been in space 5 years, but my first day I had the opportunity to get introduced by Anna and some other guys to magnificent guys in the US. One was Buzz Aldrin. The other one was Mike Hamill, who was a space security guy in the US. And they told me something I've taught a lot on since. They said, yeah, welcome to a business that is all about provide peace, freedom, and prosperity to all humanity in a sustainable way. That's what it's all about. Never forget that. And I think they are right. So please work hard to achieve this. Welcome to our reception. Thanks.
Thank you very much. And that concludes the conference. And as Stefan said, you are invited to the reception upstairs in the foyer. And I would like to thank you all for your energy and your engagement during this afternoon. So thank you very much.
And thank you, Anders.
Oh, thank you. Just a small practical detail, all the speakers and the organizers, could you stay for a couple of minutes? We will have a group picture here.